So you have.
That actually addressed it when you guys started turning on the multiple document linking, the main context center. That's when I was able to actually
Go all the way.
and work in a performance like that. Before it was just painful towards the end. Once I had like 700, 800, 900 features, that was it. It was just not possible to
That was one advantage. How many years that been? It's about been 2 years now.
First door.
No, it has linking to other documents and contacts. We don't have that.
Oh, yeah.
How many are free users? All right. And how many are pro users? All right, great. So we got a really good mix. One thing I want to point out, a couple people. Christian over here is one of our earliest. You know, we can have a contest here for who thinks they're the earliest user of Onshape in the room. Did anybody use it before public beta started? Was anybody in Alpha Club here? So, and then there was public beta, which started over 3 years ago. Christian, did you start like right away?
Yeah, I started right away when we started going at the beta.
So we had about 10 months of public beta, and now we've had about a little over 2 years of release. So did anybody start at the beginning of public beta like Christian? You did too? Yeah.
No. 3 years ago.
3 years ago. Okay, so you guys have toiled through the most over the most hard terrain. Christian actually is a hobbyist, and but a very sort of professional hobbyist. And if after the presentation you want to talk to him, he has done a model of the Zodiac.
The schooner Zodiac, and it's a 160-foot wooden schooner where all construction plans got lost over the last 100 years. And so I started to slowly reverse engineering it, and the model you see here is entirely done in Onshape and then printed on a 3D commercial printer with shapeless.
So yeah, and we were joking because some of the STL out of that was choking Onshape in the early days, and choking the printers too in the early days. So Christian persevered, and it's a very cool boat. All right, so I'll give you a quick. We'll go over it again when it starts, but it's going to be sort of rapid fire. I'm Dave Corcoran. I'm the VP of product and one of the co-founders of Onshape. I was also the VP of R&D, one of the original developers of SolidWorks, and the VP of R&D at SolidWorks. If any of you have used that system. I'm going to give a quick overview of a bunch of stuff, 25 minutes or so. We have 2 customer presentations today. One from Brandon Blue Dragon, and one from who's also involved in 3D printing activities, and has a very cool company and capabilities. And thank you. And we also have Brett coming from Synapse, and you may have heard of Synapse. It's right downtown here, but it's a very well-regarded industrial design firm that does very sophisticated design work. And then Joe, this is Joe down over here. Joe will be giving a live demonstration of Onshape. Then we'll have time for questions and answers, and then we'll have sort of an open session of drinking and time. So before we start, are there any quick questions? Yes, Kim?
In front of the camera there.
Oh.
Thank you.
Let me get my things going here. That's not a question, Kim. All right, let's make sure this works. Yeah. All right, a few more minutes. Yeah, so any questions? Nope. All right. Yes.
One time, the Onshape is branched out to sheet metal.
Yes.
And what about a CAM system?
So actually, Joe's the best person to talk to about that, but we have an app store.
Show
The app store. And our app store has 51 apps now.
Somewhere around there.
Somewhere around there.
Yeah, 50.
The other one is supposed to be done.
Well, change it now.
So it has, and I would say probably 6 or 7 are CAM apps.
Yeah.
Yeah.
So
So
we'll talk about CAM, FEA, analysis, all this.
rendering.
Rendering.
other questions? Okay, so this is going to be different from me. I'm going to have to look backwards at the slides. She's messing.
Well,
Stand over
trust me,
here.
that's probably better than the other ones were hand shots.
Well, I saw that. Yeah, that was. I realized. Like I looked over and it was, the live stream was
Yeah.
right there. So, not my best angle. So yeah, so people know we've done. We're doing 5 of these. This is the 4th one. So we've done one in Chicago, New York City, San Francisco 2 days ago, Seattle, and LA next week. And we'll be doing a whole nother tour sometime in the future, but don't have that planned yet.
Where are you based?
We are based in Cambridge, Massachusetts, and we have employees all over the world, but we have about 100 employees, about 80 are in Cambridge, and then we have a small office in Pune, India, about 5. And then we have the rest of the 15 are scattered throughout the world and the United States. I think we have 3 in California or 2. You and Cody's employees. 2. So Joe is in San Diego. Cody is about 2 hours south of San Francisco.
We'll be there in 3 weeks in San Diego.
Great city.
It is. We paid the weather though.
We did. Yeah. I left the rain for Seattle. That's that much.
Maybe you can get started.
Okay, we'll get going. Okay, so say some of the things I just said. So I'm Dave Corcoran, I'm the VP of Product at Onshape, one of the co-founders. There are 6 co-founders. So we titled this presentation the first 4 million hours. There's been 4 million hours of usage of Onshape so far all around the world. So we believe we are the only true modern CAD system in terms of a true modern architecture. So we'll talk about why we built it, what it is, what is a modern architecture for CAD. How a lot of companies have adopted it for professional use. We'll talk about that, how many and why, and then some of the things that are new in the product. There'll be an interactive demo and conversation, as Kim said, after the customer presentations. So the 2 customers that we have are both local. So we've had local customers in each city. And just to talk quickly about that, when we invite customers to come and talk, it's basically like we don't vet their presentations, we don't pay them, we don't, it's part of the community. They're doing us a favor, so thank you. But it's also tell about your good experiences and your bad experiences, and we want it to be as open as possible. So let's talk about why we built Onshape. So I was a big part of building SolidWorks. Actually, all the founders at Onshape were a big part of building SolidWorks. And SolidWorks is a great system. And there's a lot of other great systems out there that are very strong production systems. But they were all built in the 90s or earlier. And that's when they started. And so they were architected based on the best that you could do in the 90s or earlier. And that was Windows computers, Microsoft Foundation classes, and they were breakthroughs in their time. Before them, everything was either mini computers or Unix workstations, and those devices cost $30,000, and the software cost $30,000 too. So $60,000 to get going, $40,000 to get going. And the engineers or designers at the time were paid $30,000 to $40,000. So the CAD, so $30,000 to $50,000. So the CAD cost as much as the engineer. Very different today. It's a very different world. So, but that architecture, let's talk about how it worked then and how it still works now for that sort of old CAD architecture. First, everybody has a Windows computer. All of those systems work on Windows computers, and by and large, they don't work on other computers. The CAD system is installed on each computer. So already you have a lot to deal with. You have downloads, installs, service packs, floating licenses, floating licenses. And these kind of products that are architected this way tend to crash, and you tend to lose data when they do crash. You tend to lose whatever data, whatever you did since the last save. And why is that? It's because everything is based on files. And if you go back to the 90s, you'll see that almost everything at that time was based on files. So whether it was Microsoft Office or Adobe systems or whatever, everything was based on files. So to share information, to share your data, you had to share files. And to share files, what you typically had to do was copy files. So you shared your files through FTP, email, you made a copy and you sent it, thumb drives. You may have had a file server so people could see the files, but only one person could edit the file at a time. Only one person could have write access to the file at a time. So that created a situation where you tended to have a lot of copies of files, and it became confusing about which one was the latest. So, or which one people should be working on, or two people worked on them at the same time, and there's no way to put that work together. So people got PDM systems. All of these were recreated copies, okay? And you had a lot of confusion. Where's the latest version? Am I overwriting somebody else's work? Are they overwriting my work? And then with PDM, you had checking and lockout files, lockout problems. So people said, well, maybe we can bring the cloud into this as an add-on, and maybe that will help. And it does help, but effectively, Dropbox is a file sharing system. You can have cloud-based PDM, but again, you have more files. It's all about checking in and checking out files. So you have even more copies. And for any of you who have worked in professional CAD or even on significant jobs, in free CADs, this looks like we drew it to be really complicated, but in fact, it's not nearly as complicated as what really goes on. Everybody has more copies than this that they're dealing with. So you end up with a bunch of problems, and these are examples of the problems. Who has the latest version? The file I need, if you have PDM, is checked out. I'm waiting for Joe to check it in. I can't get things to work. I need to call IT, or I need to be IT. Somebody changed one of the files in the assembly, and the assembly blew up. Those kind of issues. We call this problem design gridlock. And this is an illustration of what we mean by gridlock. Every one of these guys is going to get home tonight. It's not that you can't get your job done. People do it, and then, they run into the same thing the next day. So it's just like what's shown here. Becomes part of your working day, becomes subliminally accepted, but it doesn't have to be that way. So what's different about Onshape, and why did we build Onshape? We built Onshape to be based on what's possible today. What does modern architecture allow today? And what it allows is all of your modeling tools, all of your CAD software, and all of your data to be one place in the cloud. And when I say one place, it's actually many places in the cloud. It's distributed throughout the world. So if you look at the way Onshape works, you get onto your system, it could be through any browser, any mobile device, and you're accessing your data on the cloud. You're creating your data on the cloud. And, you can access it whenever you want, from wherever you want, from whatever device you want. And there's always one version of software. There's always one version of your data. Now you can create versions of the data. You can branch, you can merge, you can do all sorts of things. But when you do that, it's very clear which one's the latest. In fact, there's a tree that tells you which one's the latest. So you're not dealing with files flying all over the place where only one person can have write access at a time. That creates some unique features to Onshape that no other CAD system has. You can restore any model to any state that it's ever been in, ever. So any assembly, any drawing, any part, there is an infinite history forever of everything that's ever been done to it, whether it was done to it by you or anybody else, and you can go back and restore to any place you've ever been. So, that's unique to Onshape. Data management is built in. There isn't a separate, you're not doing the data management, there isn't a separate PDM system. Data management is built directly into the CAD system, and we will show that. Joe will be showing it later, but I'll be talking about it a little too. You can access it from any device at any time from anywhere. Any phone, or any iOS or Android phone, any tablet, iOS or Android tablet, and any Mac, PC, Linux, iOS, Windows, all of those, any browser, any modern browser, you can access and work with. So, so the data is there. You can access it from whatever computer you have. If Joe wants to work on his model, he can go over right now and get on your computer and work on his model. But he doesn't have to do it on his computer or anything else. There is literally zero IT. There's no IT required. You just log in and start using it. It's like using a website. You don't have to do anything, maintain anything, deal with anything. Onshape virtually never crashes, and you virtually never lose data. I say virtually because there will be that one case, but this is true. This is not true of old CAD. The reason is because we incrementally store everything you do forever. That's why you can go back any place forever. And so there's virtually no lost work for exactly that reason. And it virtually never crashes because it isn't running on one CPU on one machine. There's many CPUs in the cloud that are doing that work. And there's a lot of backup CPUs running all the time. And so there's services that talk to each other. And if one service crashes up there, another service plug right in. You can share your data anytime with anybody and take away the sharing at any time. And you can share it with the level of privilege you want. You can see it view only. You cannot download data from it. You cannot share it with others. All of those things within your control. We believe the CAD's better too, and I'll go into a little bit of that. Joe will show some of that. We've had another 20 years to think about it, and so we should have been improving that too. And what's our goal? Our goal is to allow you to be a full-time engineer or designer, not to be a half-time IT specialist and a half-time designer or engineer, or an engineer that's constantly waiting for the IT guy to make things work for him. So we believe we're the leader in modern CAD. We have thousands of companies that have purchased Onshape today. 73% of those companies that are professional users state that Onshape is their primary CAD system. So this is, in my opinion, fairly remarkable because we are trying to get into a penetrated market. Unlike when we started SolidWorks, or when SolidWorks was starting, I was there. A lot of SolidWorks users, most SolidWorks users were 2D users before they got SolidWorks, and they couldn't afford the 3D CAD, as we discussed, that was out there. We are very much a penetration market. So we built our system to work well with other systems, and also, but still, of the people who have adopted it, 73% now consider it to be their primary CAD system. 4 million hours and counting. So we have 4 million hours of usage so far. That includes our beta and our 2 years of release. Most of it has been during the 2 years of release. So that's a lot of hours. It's all over the world. So we have a well-tested, well-tested, really used, distributed worldwide infrastructure. Onshape is the only CAD system that runs fully on mobile devices. So I've talked about the mobile devices, but our mobile devices aren't a viewer. It's not a separate product. It's not like something like eDrawings, where it's a separate product that's a viewer. It's Onshape. So Onshape is running on the mobile devices, the whole thing, and you can do all the editing you want. So it's the full CAD product. 1 of 8 sessions of all of the sessions over all those years is on mobile. And we are #1. You can Google G2 Crowd Onshape and read a bunch of reviews, but there's a section specifically on CAD. We are rated #1 in customer satisfaction. We verified this with a number of other surveys. One question is, so we're the youngest product out there, so why are we, #1 in customer satisfaction? There's a couple reasons. One is we do really have great support people, like fantastic support people, and Christian can talk about that. But anybody, I hope that other people here who are customers feel the same way. We are very responsive. But another big part of it is our architecture allows it. And what that means is when you're in Onshape, if you have a problem, you can go to the feedback tool, you can snap exactly what your problem is, you can sketch on it and point it out. The database is stored every step along the way. So we know exactly when you reported the problem and what the problem was. And you can right there, you can click a button that says share this with support. So we can't see your data if you don't share it with us. But if you share with us, we can get in that document with you at the same time and figure out what your problem is. If there's a workaround, we can offer that workaround right away. If it needs a bug fix, or it needs to be verified that it needs a bug fix, we get the developer right in on that same document at that moment. So it isn't reported to a VAR. The VAR has to send them a file. The VAR has to bring up the file, reproduce the bug, talk to you. He reproduces the bug. He sends it to the company's support organization. The company now has another copy of the file. He tries to reproduce the bug. He reproduces the bug, sends it to the R&D in the company. They now have another copy of the file. They try to reproduce it. They finally reproduce it. They're not going to release for another year. So you're not going to get the fix for another year. We release every 3 weeks, and we can release every day. So and Christian knows when things are really bad, we do release. When there's something that somebody's really holding up, we will release, within it as soon as we have it figured out. So that's why we have the best support, because we have the best responsiveness. Part of it's having great people, but another part of it is having an infrastructure and an architecture that allows it to happen. These are some of the reports on G2 Crowd. All of these ones are going to look positive. I didn't put the slides together, but if you go there, every one of these people is asked, what do you like best and what do you like least? So if you want to get a good, honest opinion of pluses and minuses of Onshape, Google G2 Crowd, Onshape, and it will take you to the CAD section, and you can see your own opinions, or you can see honest opinions. This is our release schedule last year. We released, as I said, every 3 weeks, so about 17 times a year. These were all the enhancements that were in each release. I know you can't read them, but trust me, they're good. But yeah, every 3 weeks. So nobody releases this fast in the CAD industry. And so we're the fastest moving, and this is continuing now. So every 3 weeks release. One key thing about our releases is that you don't have to do anything to get the release. You just log in, and you have the new functionality. You will get an in-app message that will come up, which has said there's been a new release. Click here to see what's new, and you can go there and see what's new. We have a forum. You can see what's new. You can see what's new for each one of these releases. So again, no IT. You're always up to date on the latest version. Everybody in the world is always up to date on the latest version. You never have to upgrade your software, worry about mismatches. You never have a situation where somebody else is on, old CAD system 2017 and you're on old CAD 2016 and you can't open their files. That can't happen in our system. If we fix a bug for you, when you log in, that bug fix is there. You don't have to do anything to get it. You don't have to reinstall it. You don't have to install a service pack. It's a different world. As we were discussing, we have 51 partner apps across all the different disciplines: simulation, machining, rendering, and Joe will talk about that a little. But our sort of premier type of app, we have different levels of app. Our premier type of app is called an integrated app, which basically means you can go to the App Store. You can say you want to try it. It's enabled right then. You can use it and try it. All of them have a free option. Some of the free options are like limited trial, but all of them have a free option. You can try it out. If you want to buy it, you can buy it right then. So a lot like the App Store, the iOS App Store. So here's some of our apps: analysis apps, generative design apps, rendering apps. So this is one of our professional users companies called Cutsport, which is a local company. And I'm just going to play a quick video. So I'll take a couple minutes of them talking about their journey to using Onshape.
love innovation. I'm making something that doesn't exist. That's the way to live for. If you don't like change, you're not going to be happy. Because when something better comes along, we're going to try it. We make products for the power industry, brush holders, shop grounding solutions. Depending on the size of the generator that we're making parts for, any delay of 10 to 24 hours is going to cost hundreds of thousands of dollars. And we have a very small window in which we can get in there and do maintenance and install the parts that we design. If you start with a tool that's prone to errors and prone to delays, you're just going to have that ripple effect all the way down the stream. I use SolidWorks for 15 years, and so I know CAD. The problem was my computer would crash a lot. Our old PDM system required a lot of check-in, check-out, send for approval. We spent a lot of time managing that. We're product development people, so we're not in the IT business. We just want to work on parts and innovate new solutions. We don't want to deal with zeros and ones. We believe in a cloud solution. Getting out of the IT responsibilities of CAD, we're coming from a vault size with over 15,000 files and 60 gigs of data that goes back 10 to 12 years. There's a number of reasons that convinced us that Onshape was the right tool. Finding out that we could use simpler computers and just have the CAD run in an internet browser, that's what really intrigued me first. How we chose to do it was to take one guy, have him go complete Onshape, and see what he thinks after just living in the world of Onshape for a few months. I was the guinea pig and kind of just take a first look at it and see what would be beneficial for our company. It didn't take very long before we were seeing, wow, this tool is really becoming useful. You get all these advantages of new technology where old CAD is just stuck in those limits. I was really blown away at how simple it was, how everything can be funneled down into this one workspace. In Onshape, there's much more freedom to focus in on what you're working on. You're not bogged down by the CAD, you're not limited by the CAD software. The CAD actually supports you instead of limiting you. There was one point where I had to go back and actually use the old software, and I was just so frustrated. I would never want to go back.
If you remove those distractions and you can just focus, to be able to just break down those walls and you can go beyond those limits, that's the glory of Onshape. That's a wonderful thing right there.
I'd say the reason we moved is we wanted to get better. We wanted to get faster. We wanted to be more efficient. I'm a big believer in if there's a way to get better, you do it.
Do what we do best, do what we enjoy, and create.
Sorry about all the noise just a while ago when everybody's leaving. If you have another one to play, we do have the speakers.
Oh, okay, thank you. Okay, so let's get going again. Okay, so I want to jump into, so that was Cutsworth, one of our customers. If you want to see more of these video testimonials, just go to Onshape Customer Stories, Google Onshape Customer Stories. I think we have 5 right now, and we have a lot of also blogs and case studies of customers on our website. Recently announced, there's been 2 sets of things. Joe is going to be showing these later, but I'll just run through them quickly. So these are all things that were announced this year: Parametrics 2.0 and Data Management 2.0. Parametrics is about modeling, so things that have to do with parametric modeling, all things that we innovated in and sort of improved the paradigm. So the parametric modeling paradigm has been around for a long time. It was introduced in 1988 by PTC with a product called Pro Engineer. It's been the dominant CAD paradigm pretty much ever since then. There's other paradigms that are used. There's direct editing with no history. We have direct editing in our product that works within the parametric environment. But really, if you've been using existing CAD systems in the last 15 years, not much has changed in terms of how parametric modeling works. Except in Onshape, we have gone back and changed a number of fundamental things. So that's one of the things that we'll be talking about here. 2 of those are configurations and standard content, which were released this year. So we've tried to put a label on this and call it Parametric Modeling 2.0. Here's some of them: simultaneous sheet metal. In our sheet metal, unlike other systems where you have to roll forward and roll back to fold and unfold, flatten and unflatten things, you have 3 views of the model. You have the folded up model, the real model, you have the flattened model, and you have the bend table at the same time. And those are in sync at all times, and you can edit in any of those views, and the other 2 views will be updated. So, for example, a lot of times you do something, it turns out it can't be flattened. You know it immediately, as opposed to not finding out until you've done 20 things and then go to try to flatten it and it says, I can't do it. Change things, the order of things in the bend table, turn rips into bends, bends into rips. That can make it non-flattenable. You'll know that immediately. So those are the kind of things that really, how would I say this? The kind of things that really waste a lot of your time. That's really what we've been about with Onshape. We're trying to get the IT overhead out. We're trying to get the inability to access the system out. We're trying to get the confusion about who has the right data out so that you can do your real work as effectively as possible. Configurations Joe will be showing, right, Joe? Yep. But we believe we've made a major improvements there. In standard content, multi-part part design, in context design. In context design, if any of you have used older CAD systems, you know that they can blow up. We've created a way to do it that is guaranteed not to blow up. Data management 2.0, I'm rushing because I'm behind schedule. Kim's giving me the eye. So we have eliminated the need for PDM systems. And so the data management is built in. You don't have a separate, add-on that actually serializes your process. So no PDM anymore, and it's much better. These are some of the aspects of data management that we innovated on. Because everything's in one place, you can do advanced search, and you can search like with documents, or with Google search, you can search for particular keywords, particular things. And this is real time. This is searching on your data. If I'm in Australia and you're in the United States and you have the ability to see my documents and I add one and you search, you will see it that instant. It's not after I check it into the PDM system that it might become visible to you. And if you don't use a PDM system, it never becomes visible to you until I send you the file. We have built-in version and branching like GitHub, like Git, so multiple people can collaborate on a design together at the same time, like Google Docs, if you're familiar with that. You can also choose to branch, create your own version of the design and work on it independently and merge it later. That's all built into the system. You can compare with that real-time sharing and collaboration we talked about. Simultaneous BOM basically means as you build your assembly, your BOM is built for you, and that's simultaneous. And just like sheet metal, you can edit in the BOM table, or you can edit in the graphics window the way you normally would. So all of that is done for you, and Joe will be demoing that. And then release management, as I said, is built in. So in release management, you build release packages. That is not a blocking thing like it is in PDM, where you have to check it in and nobody can access it until after you check it in. That package is made, it can be approved or not. Joe will show that. And so here it's an example of somebody approving on a phone. When you're in the approval process, mobile is a great thing. You don't have to go back to your office or back to your house, bring it up on the one place you have your old CAD system and your old PDM system and go through the approval process. So no more of these issues to do with data management. It's all integrated and it's all real time. That's it. So what's next?
So next we have Brandon from Blue Dragon.
So Joe, we need your
Let's move this.
plug. Do you want to use the computer or a clicker?
Whatever, the clicker would be great if this happened.
Onshape is excited to announce simultaneous
Whoa.
material.
Yeah, so you just
Give me your laptop. Yes, sir. This will be the only laptop exchange I think of. All right, stick. And
Brandon.
have one, that'd be great. I think I could probably project without it.
Is there audio coming out of this? Because we do audio.
Do you need audio?
Nah.
All right, I think we're in pretty good shape.
Try this right next to each other. Sweet. Why'd you click? See if it works. Yes.
Hey, it works. All right. Technology. Power, we probably should hook up power to. Did you? Oh, you did. Good.
All right, so a lot of really good technical information today. I come more from the business side. My company designs 3D printers, and we ship them out all over the world. We're SolidWorks people traditionally. We made the switch to Onshape. This is my Dave, by the way. He's the closest thing we have to a CAD wizard over at Blue Dragon. But that's been about a year, I think, for us heavily using it. I'll tell you a little bit about what we do. So basically, I've been involved in 3D printing for a good 5 to 7 years. I've worked for different companies. Through that process, I learned a lot about 3D printing and about how to render, how to take these great ideas and to, more quickly iterate them, develop them, bring them to market. And I never quite got the ability to sell the printer that I always really wanted to sell, something that really allowed, any one of you to be independently powerful without having to go to like a Shapeways and do a lot more with your designs. But basically, what we've done is we've developed an entirely new type of way of 3D printing. We redeveloped the whole nozzle system, a whole delivery system for molten polymer that allows you to actually deliver 4 types of materials simultaneously. So you can not only just 3D print something, but you can integrate 4 completely different types of polymer at the exact same time as you're printing. This allows you to do just very intricate productions of whatever it is you've designed. So we've been able to stay relatively lean. Part of that is through leveraging design software and partnering with people all around the world and being able to interact with those folks. One of the big pluses we've had is with Onshape is just the ability to collaborate, the ability to seamlessly collaborate, and not just with people that are Onshape users. We're able to collaborate. If we're working with someone on the other side of the world and they don't even use Onshape, they can get a free account and we can give them access and they can start giving us feedback right away. And so it's really easy to collaborate and keep your team small. A little bit about where we place in 3D printing right now. There's this industrial 3D printing that you hear a lot about that's been around for 20 or 30 years. Then there's like this low value, very hyped consumer 3D printing, which, it's not very practical. There's been a lot of press about it. Where we kind of fall is right in the middle. We develop our printers basically for those small and medium-sized businesses and those entrepreneurs that are really trying to leverage their designs and their ideas. And so not only do we make the machines, but we actually now manufacture materials. We co-develop software. Basically, for real success in 3D printing, you have to actually have this full scenario because a lot of people jump into it, they buy a machine, and they have a lot of issues because that's not the only piece. There's multiple pieces to 3D printing that all have to work, extremely well. And if anyone has any questions after the presentation, I'd love to go into that in depth with anyone that's interested. Currently, we have some really great projects. We're working with a number of companies. One company in particular has developed a footbed that basically can be custom modeled to any single individual person's feet. And this footbed is like perfect for that individual person. But we layer a biomesh on it, and it reports something like 91 data points on the individual. You can actually basically recreate your entire skeletal structure from that data. And then that data can be leveraged in so many ways. They actually have an app, and you can give your doctor access to it. And as you're moving around during the day, he's able to get live data from those footbeds that they give you, that allows him to kind of diagnose whatever issues you're having. So being able to rapid prototype these footbeds for this customer has been like a major groundbreaking thing for that customer. In addition, we're now working with the military because the technology is going to be leveraged into soldiers' boots. Because they have something like 2 million injuries a year in the military, and they think they can. This will allow them to prevent about 750,000 of those injuries. So being able to quickly iterate, design, and then print output is it's extremely powerful. The biggest thing for us with Onshape, and really what not just for us, but for our customers. Because now that we use it heavily, we're encouraging all of our clients to use it. The biggest thing for us has been data loss. I think the original conversation that I had with David, he had some of our assemblies are massive, right? Because we manufacture these 3D printers from the ground up. We do sheet metal, machine metal, we do printed parts. I mean, the entire assembly is quite large. But basically, we were having crashes with SolidWorks. Every once in a while. How often would you say, David?
Oh, weekly I run into something.
Yeah, and it wouldn't be like a lot of data loss, but it's still work, right? And so that was a big deal. When he started talking about that, I started looking around for other options. And that for us was kind of like, that's kind of what kicked off the search. We started working with Onshape. At first, we were using it just to develop independent components that we would print. And I think through that process, we learned a lot because the collaboration tools came into effect. We do some off-site printing, we do some on-site printing, and then we started using it for our machine components. And that vendor collaboration where we're not sharing, basically pre-Onshape, we were sending out drawings, we were sending out intellectual property on some pieces that were quite important to us. At this point, we literally just sending these shared links. We're in full control and knowledge of where our intellectual property is going, who's using it, and I don't know, it gives me a ton of comfort to be able to do that. One of the other cool things that we've done in the last little bit is we started working with some of the local colleges to expand our design team, and we have an intern program. And these kids have all learned much more traditional CAD programs. And I think in the span of about 5 or 6 weeks, we were able to convert these kids completely over to Onshape. And the best part was how Onshape offers like student licenses to any student. And then we're able to just give them access right into, or specific access to the specific files or lessons that we're trying to teach them with to get them up to speed to be able to work with us. And that's been just amazing. So from that perspective, those are kind of the 3 big things that have really, from my perspective, given Onshape just a great reputation with me. As far as from a technical standpoint, Dave, what would you say like the biggest difference maker has been for you?
Just being in the cloud and data management is probably the biggest thing. It's really nice just having it all in one place, and you never have to make sure you take the files home on a thumb drive or whatever it is you have to be working with.
And not only that, I think the maturity of the product at this point, the sheet metal. See, before, the reason we didn't look at Onshape early on was we work with we do a lot of sheet metal, and when that sheet metal came online, I think that's when we really got deep into using it, and really haven't looked back since. And we haven't had any problems. I mean, not one problem. And so that's big for anyone from a business perspective. I mean, I know my team is able to consistently work, and I think Dave touched on it so many times. You know, you're designing, you're engineering, you're not doing IT, you're not struggling with your systems. We've had computers that have gone down, and we just move over to the next. We just move over to the next laptop. We just move over to the next PC. It's fantastic. So yeah, I love Onshape. Appreciate everyone coming today. Thank you. Any questions?
Where are you located?
Just here in Seattle, down in Inner Bay on 15th Avenue. Hard to miss us. We're right there by the Whole Foods. There's a big building, 1631 and 15th Avenue West. Come by anytime if you want to see some amazing 3D printers. Anyone else?
You have a business card?
I will get you one. This mic's live and there's no switch.
I'll hold it until that.
Yeah, it's a bomb.
Don't drop it.
Yeah, you got it.
All right, so thank you very much.
Thank you.
Thanks, Brad. Brett, you're up.
So Brett is from Synapse, which is also a company that I was just at down the street, and a fascinating design company. Do you want this, or do you want to?
I do.
Project? Okay, there you go.
I would prefer to project, but I've been a little under the weather.
I'll get out of your way.
Thanks, David.
Do we need to get? Do you need?
Oh, sorry. I guess I can.
Come on, Joe. Can hire good people.
We'll get started here. So I'm Brett Richmond. I'm the Director of Mechanical Engineering at Synapse Product Development. And this is Will Harrison. He's one of the mechanical engineers on my team. We're excited to talk a little bit today about Synapse and our experience so far in evaluating Onshape. And I just wanted to say thanks to the folks at Onshape for giving us the opportunity to share that experience and to connect with more people in the Seattle product development community here. First of all, who is Synapse? What do we do? We're a product development consulting firm. We're focused primarily in the engineering realm, but we have a wide range of capabilities that we bring to bear on our clients' product development challenges. And I've been at Synapse for about 8 years. I started out as a mechanical engineering contractor. I've been a technical lead on a number of projects, and about 3 or 4 years ago, took over the team and have been responsible for, among other things, developing best practices for our team, tools, extending our capabilities, and so forth. Will, do you want to talk a little bit more about us?
So yeah, so I've been at Synapse just for a year now, but I was working for our partner company, Cambridge Consultants, for the previous 3.5 years. We actually have offices all around the world, taking in over 700 engineers and other applied scientists, all working in product development. Our offices cover North America, Europe, and Asia. We've built our reputation on innovative product development and really giving our customers the best solutions and keeping them at the forefront of their particular markets. Yeah, so we've worked with a huge range of companies across a diverse range of markets. So we have mechanical, electronic, software engineering, and we really thrive in the really challenging multidisciplinary projects. And this is where our strength lies and where we really differentiate ourselves from industrial design firms who we often partner with to be able to allow these clients to achieve their goals. We often come in when clients are moving outside their comfort zone, so they're starting to do something new, moving to electronics when they were making purely mechanical products before, or trying to utilize new technology. So this wide range of clients also is reflected in our wide range of market sectors. We work across consumer electronics to medical devices. And personally, I've worked on everything from beer dispensing to industrial IoT sensors. And that diversity really allows us to transfer technology and ideas that we come up with across these markets. The best example I've got is we developed a spray nozzle technology for an inhaler, and that's actually been transferred to cosmetics, and then more unusually actually transferred to the agricultural sector. So this is where we really have our strength of transfer technology, and we have everything from optical physicists, mechanical engineers to genetic engineers that really allow us to leverage all these skills. And the global presence gives me the local partners to big companies like here in Seattle, but then we can also draw on these specialty skills that may be based elsewhere in the world when we need to.
Yeah, so as Will said, we're able to tackle these really tough challenges by having a wide range of discipline representation under the roof and investing in advanced capabilities. We really thrive with these really difficult trade-offs that exist across traditional discipline boundaries. And I think one easy example from the consumer sector, which we've worked a lot with here in Seattle, is the trade-off between aggressive industrial design targets in terms of geometry and size, battery life targets, and then your feature set, right? So whether they're UI features or RF performance or whatever those things are, we're basically trying to pack more physics into the package than really wants to fit most of the time. And that's where we really perform well. Our approach is to understand those trade-offs as early as possible in the process so that we can address them head on and essentially prioritize our concept development activities to de-risk subsystems and key integration points. One of the things that I like to talk about is it's not uncommon in these early concept development activities to see one of our PCB layout designers sitting at her desk with an electrical engineer, an RF engineer, and a mechanical engineer standing behind her, pointing at her display and talking about, I need to put an antenna there, I need to mount the board there, I need to put a high-speed data line there. That's the kind of world that we're living in every day. Synapse has been around since about 2000 or 2001, and the culture's evolved a little bit over time. Certainly, we've emphasized the softer part of our culture that help us attract and retain top talent and put together, flexible, dynamic teams. But there's a concrete part of our culture which is not unlike a lot of other companies, which is while our teams are working on their projects for our clients, we want to focus on developing the best solutions to fit within that client's constraints and meet their objectives. And we want to remove the noise as much as we can. And in fact, when our engineers are between client projects, they're often focused on helping to eliminate that noise, whether it be through developing design guides or best practices, or they're working on some sort of capability expansion or skill expansion for the team or for themselves. So I had to dig back through my email, but I reckon we discovered Onshape in early 2015. And it was around that time we had been through our annual process of identifying organizational opportunities for improvement. And there were a few of those items that we thought Onshape could probably help us with in the longer term. One is the increasing pressure that we all feel probably every day to decrease time to market. Another was some cross-discipline friction points that we knew we had that led to some unforced errors here and there, which we're not proud to talk about, but it's reality. And we knew we were spending a fairly significant, or at least non-trivial amount of time on IT activities in terms of PDM and CAD admin, and that's both with our IT team and with people on the mechanical engineering team contributing to that. So once we were acquired by Cambridge Consultants, we knew we faced additional challenges when it came to global IT integration. And CAD and PDM integration is a pretty sticky challenge when you try to do it globally. A lot of our system integration has been, I guess I'd say that the pain points with those are localized to smaller groups of people. So if we take and integrate our Salesforce systems, and we integrate our HR systems, and we integrate our accounting and finance systems, it's not fun for those people, but it affects a relatively small number of people. When we start integrating CAD and PDM, it starts to impact a much larger number of people and their billable individual contributors on projects, and so that has its own challenges. The other thing is that the way that we're arrayed around the globe, we have, I think, really nice opportunities to maximize the number of hours per 24-hour period that people are working on our clients' projects if it seems valuable to put cross-geography teams together. And we only do that if there's value for our clients. But it means that we need to have clean data transfers twice a day, every day. And the challenge for us is that we have to invest enough time in communication to prevent costly mistakes, but not invest so much that we're basically being inefficient and flushing minutes and hours down the drain. I don't like the thing where someone in Seattle is staying up till 11 at night to work with someone in the UK who's working until late in their morning to figure out the CAD stuff so that they can then be on their way to doing their work for the day. So that's a big challenge, and Will's going to talk about some opportunities.
Yeah, so I think a lot of them are very much related to the challenges that Brett highlighted there. But Onshape has some opportunities to help us get past these challenges, particularly related to collaboration and data communication. So removing a lot of the IT overhead, so reducing the PDM workflows and communicating data between the teams. There's the reduced checking in and exporting files as we need to. There's different versions of CAD. There's the opportunity for people to be viewing things live as it happens and commenting on the CAD as it goes. So this expands well beyond just our mechanical engineering team. We're developing an optomechanical system. We can have our optical physicists have, as I said, like a free view-only account. We can link them the file, they can view things, measure, check that our optomechanical design is meeting their requirements for the optical system, and make suggestions and comment as we go along. Removing the version management means everyone knows they're always seeing the latest version of the CAD, and it's certainly been a help to, certainly an opportunity there for us to be able to collaborate more quickly. We can also look outside of our own organisation, so collaborating with clients. Again, if they're not working in Onshape, you've got the opportunity to share with them view-only CAD. They can see this, comment on it, and you're giving them the opportunity to see things live. You've got even more opportunities if you're working with clients who are working on Onshape, where there's the seamless collaboration opportunities. You don't need to worry about PDM systems and integrating these, and having to define very hard interfaces, which are projects I've worked on before, where we're working with different consultancies or with clients, which are defining the interfaces of this subsystem and this subsystem. Whereas now with Onshape, there's a chance that we can do that all within the CAD system. Again, suppliers, you can send them a link to the CAD. You don't need to export. You can make sure you know the versions. And yeah, removing system administration overhead is huge. The amount of time that is spent on PDM work, particularly with our mechanical engineering team. So it's not just IT, but mechanical engineering team who would otherwise be doing design work for our clients. We can reduce that time. That's valuable for us and our clients. But despite all these opportunities, there's always challenges in adoption of a new product, particularly in a company where there's a lot of history of people who've worked in SolidWorks predominantly. They've got tens of years of experience and skill in that particular application. And with the pressures on time to market, they're reluctant to invest the time they need to move to a new tool. They also see the limitations in new tool when you're first testing it out, and very good to jump on what doesn't work for them or what's different, and very almost reluctant to see what just works. That's not always seen as a positive. They see the issues with it. So we've got the switching cost at the individual level, and also the fact that people have seen other tools out there and they're not sure which is the right one to go to, and we've already got one that works. Within our consulting view, there's also the challenge of our clients sometimes define the CAD systems we use. If they want the CAD at the end, in Creo or SolidWorks or whatever other system they're using, then that's what we'll do it in, that's what we'll work in. But there's certainly challenges there with getting adoption. Yeah, we've had some efforts at getting buy-in, and Onshape have been hugely helpful in giving us quick support and coming into the offices and discussing with our engineers, but there's going to be ongoing work as we look to adopt it a bit further. And back to Brett.
You want to talk about your project first?
Yeah, so I'm actually working on our first client project who are also using Onshape. It's been really successful so far. We're not using or leveraging the full collaborative tools simply because we haven't needed to. We've been brought in because our client don't have the time or the resources to invest in this project. But we've been able to quickly receive the CAD for the subsystem we're integrating with, get that and work with it, knowing that it's going to integrate well and fit with all their requirements. And at the end of the project, we can hand it straight back to them, and they'll be familiar with it, can make changes if they need to, and update with future versions. It's also been great just for client communication. So as we're giving them our sort of weekly status reports, we can show them the CAD, and they'll be able to just go and spin around it, see what it looks like, see the progress we're making, and really gain confidence in our engineering skills and how everything's developing.
Thanks, Will. So where we are right now, also looking for the next 1 to 2 good client project opportunities to use Onshape. Some of the criteria we're looking at there are basically speed, like obviously how fast we need to go. So in some sense, we're almost looking for almost more risky projects to try it out on, because that's where we really want to kick the tires with it. And I'm pretty well convinced it'll help us go faster on those kinds of projects. We're implementing a few reference designs for development tools that we commonly use internally in Onshape. So, for example, we have a few different test fixtures that we tend to copy and then customize for different applications for different projects. So we're implementing those in Onshape, and then we're going to share them with our compatriots over in the UK at Cambridge Consultants. And then we're encouraging internal project teams to use Onshape as well. So we do internal projects for capability development or demonstrations and different purposes. So we're looking for teams and guiding teams to use Onshape for those. And then really we're on the hook between Synapse and Cambridge Consultants to figure out our MCAD approach this year. And there's a lot of conversations about Onshape as a part of that, and at least using it through concept development stages where we're churning through a bunch of different architecture options and trying to figure out what the right solution is, and then giving teams, likelihood then would be to give teams the flexibility to use whatever CAD system they want after that point. But that's where we are. It's been a fun road so far. We've got really great support from Onshape. There's more evaluation we're going to be doing, as you might imagine, but so far so good. And thanks again for the opportunity, and thank you all for your time. Any questions? Yes.
You mentioned huddling around a computer and trying to figure out, MCAD, ECAD integration stuff. What's your opinion so far on that portion of the?
That's a good question. We haven't kicked the tires real hard on that yet. Will has integrated some electronics into his project, and I think that's been just some basic IDF conversion.
Yeah, well, it's been our ECAD team moving to Altium, so they're exporting step files and I'm importing them in. So that's how we've been doing it so far, and it's been a pretty robust workflow. But we'll certainly be looking at IDF imports and other options as we move forward for sort of the electromechanical integration.
Yeah, I think one key point on that though is that it's really nice for our EEs and RF engineers and ID and others to see where we are today, right now, as far as the physical design goes, and not having to say, well, can you send me an e-drawings file, or can I get a CAD draw? So at the very least, that's nice, but I'm excited to see more ECAD integration as well.
What about converting any of your existing projects and moving them from, for instance, SolidWorks into Onshape? Have you tried to do that, or does it make sense to do that at all?
We haven't done that. There's one of these internal reference platforms, so basically an in-circuit test fixture, that I initially started to do that, basically try to do it as directly as possible. And that, I think, works okay, but rebuilding it in Onshape afforded a bunch of opportunities to make it more customizable within the tool. And it was an easy thing, so it's really quick to remodel it. But that's the only thing that we really kind of tackled that. And I don't foresee, well, I could be wrong about this, but I don't foresee trying to do that with any of our client projects or anything like that at this sort of like parametric design level.
I think that's actually a really important point too, is that, a lot of times that doesn't make sense. And I think a lot of times people, when they look at, oh, there's this new CAD system, we're gonna have to change everything, we're gonna have to rebuild everything, we're gonna have to import everything, really you don't. And a lot of times you should keep multiple CAD systems, and you should, if that design, if it needs an iteration, it's better to go back to that design system and do it more often than it is to make the investment. And that's one thing we're cognizant. We don't believe it's sort of like, we're going to devour all this company's CADs. It's all going to be Onshape CAD. We don't think that's realistic. We don't think it's the best way. The goal is, we really want to be a good, coexistent technology that people use as much as possible.
Yes.
Speaking of that coexistence, have you guys tried to import any, other types of CAD files in there? Steps, adventure files, have you worked off of them directly? Can you build assemblies around them? What's your experience with that?
Yeah, so we've imported a lot of step and other neutral formats for kind of off-the-shelf components, and no issues there. I've imported a few SolidWorks assemblies, and I wasn't trying to integrate those into a new design in Onshape or anything like that. So I haven't tried anything like that. Obviously you can't pull those things in and get a parametric feature tree that you can then work with. But But as far as neutral formats, we haven't had any issues with that, I don't think.
I wonder if you guys could comment on the work you've done with maybe apps for FEA, maybe some rendering or bonds, that kind of stuff.
Yeah, so we've done a little bit of work with the FEA tools, but not enough for me to provide any insightful comments at this point, unfortunately. I looked at a couple of the BOM tools, and there's the one that I think Lou developed. We looked at that briefly. We just didn't really have any goal there with that. We were just kind of playing around, exploring it. I am really excited about the simultaneous BOM capability. I started playing around with that the other day, and it's really nice because you have, I mean, the BOM's right there. You don't need to go over to an assembly file somewhere else or a drawing or whatever to get at it. And I haven't really tapped as deeply as I can into that capability yet, but I see a lot of opportunities there to reduce some friction on file, Excel spreadsheet management and so forth. Are there any other? There's one that we need to evaluate, I think, and we haven't yet, which is the is it the power surfacing app? Yeah, we really need to dig into that. We haven't done that yet. And then I think there's been some talk lately of trying out the one or two of the CAM apps as well, but that's also kind of right off the printing press, so don't know what's happened there.
Just to jump in quickly, if any of you have any questions about apps, Joe's going to talk about, but Joe runs that part of the Onshape.
Yeah, I think the next one is definitely the CAM app. We've got our own little toolmat mill, so we're certainly jumping on that to prototype things. As at the moment, we're using a variety of other options with mixed results, so it'll be really interesting to try that one out.
My R&D team works a lot with a lot of different engineering disciplines on our team, and you guys would be good to answer this. You found Onshape to be lacking just capabilities compared to, say, SolidWorks or IT or anything like that. We have like RF engineers, mechanical engineers, electrical engineers. Have you found any tools that you wish you had in Onshape?
So far, to the question of have we found anything we wish we had, I don't think so. One thing that we were concerned about for a long time was surfacing, and that's come a long way in the last year or so. We haven't done a head-to-head comparison on surfacing with Onshape or any other tools, and that's part of the reason why I brought up we're excited to try out the power surfacing app. And I think if we are really honest with ourselves, we fancy ourselves some really good surfacing designers, and we are quite good, but the amount of times that we have to really deploy a bunch of complex surfacing operations is actually fairly limited. So I think it's important in some of these discussions to be realistic with yourself about how much you use some of these things. But when you need them, right? I'd say the bigger challenge, and actually when Dave was in this morning, we talked through a bunch of this with the team, but there's a few things that the mind's a little bit different than you're used to in SolidWorks or other tools, certainly other tools. But I think when you're doing solid modeling, it's pretty close to a one-to-one. A lot of the methodology is the same, etc. There are some things about top-down design and assembly structure and so forth that are not, I don't think they're worse, they're just different. And so people have to wrap their heads around that. And that's been kind of our biggest challenge so far. But it's like learning any new tool, in my opinion, so far. Yes?
Do you do much with feature scripts internally? Or I leverage the wrap script quite a bit, but that's done by somebody else, and I just use their work. Do you do any internally or mainly rely on external
I actually just posted the other day on we have a ME Knowledge Share Slack channel. Oh, hey, everybody, don't forget about the feature script tools that are out there. There were actually a couple of surfacing things that I heard a couple people grousing about recently. They're like, oh man, I wish there was an extend surface functionality on Onshape, blah, blah, blah. It turns out there's a custom feature script for it that you can just pull in. So I don't know how, I don't know how good it is in terms of continuity, et cetera, but there's some of those things that are there, and definitely go explore in there and see what you can find. I posted that, obviously, that was kind of coincident with me going through the list and looking around, and there's some cool stuff in there that might be really applicable to your domain that makes it a lot easier for you to do what you do. So.
But do you have anyone internal who's kind of a guru
We
and
don't.
looks into that and looks into it for your team?
No, we haven't had anybody write any custom feature scripts, for example. I could see potential cases for that, but from a project standpoint, what we do is so different from project to project since we're in consulting that I don't see a ton of opportunities for us to consolidate a bunch of typical features into single feature scripts.
So we have one more question, because we're going to have to get on to
Onto a good grade.
So any more questions? One more question?
Yes.
So I know you guys are more on the kind of prototyping and product development end, which collaboration tools can sound awesome for you guys. But as far as like going all the way to production with drawings and those kind of things, controlling those, have you explored that end of Onshape?
We haven't done that yet. Will is closest to that. It wasn't that recently, but we went through a whole exercise to get our drawing templates all built up in preparation for that. I look forward to doing that more, and actually Will brought up something earlier about supplying or sharing with suppliers at times.
Yeah, so I've certainly been looking at the drawings and capabilities there, and they seem like they're evolving very quickly. It seemed like that when it was early on, it was sort of lagging behind, but the drawing is certainly catching up quickly. So yeah, sharing directly with the suppliers is certainly going to be helpful, but sometimes you obviously come across suppliers where they still want their neutral 3D CAD and their PDF. So that's still what we'll be doing. But yeah, Brett worked with the Onshape team to import our drawing templates, so they look exactly like our drawings that come out of SolidWorks. So we've got that continuity, which is really nice. But yeah, we're sort of still working on it, and it'll be interesting to see. The next phase of the project I'm working on is going to be drawings and tooling, getting all the GD&T in there and everything. So yeah, I'll certainly be exercising it heavily then.
Okay, so thank you very much, guys.
Thank you.
And
Thank you.
I think both of these companies are coming. So first, both of you, thanks very much for coming and doing this. They're helping us out, so we appreciate that. And like we said, we want you guys to go to that. Right now, we're gonna let you guys get some drinks, and then come back down and we'll do the live. Okay, so there's drinks up here in the kitchen.
We're gonna take about 10 minutes, or what do you think?
About 10 minutes, yeah.
Thank you so much.
Yes, oh yeah, if you haven't gotten a t-shirt, please grab a t-shirt.
Graduated high school in 71.
No, really.
And then that's in Seattle, but I got a billboard that said last person in Seattle, like, laid off like. So my house was right now.
I know.
So one of the transitions, and done well there.
We're on, basically, each
integrate some sort of business. First of all, art died into the basically, if you're using the problem, the first problem is the element itself. The second problem is when you're dealing with nuts, it creates
And also,
Yeah, I've been thinking about how to do it, and I'm like, I don't do
So, basically our first gen, gives you a tremendous capability to do just what you're talking about. If you're being able to get in that place, that's gonna require, kind of like what I said,
so
3D printing as much as it's about software and material too. It's a challenge to actually have.
I had some inventions like that.
A lot of people out there are trying to take printer,
Exactly, they're just keeping a little bit in there, and I've also seen other ones. Yeah, I've also seen other ones, they're doing their screens. Like a print.
Right.
Yeah, and I've never seen a palette, I've never seen the other one too.
Well, splicing together different things like
it's like you gotta print it out very small amounts.
And my son, who was kind of here tonight, couldn't say, my parents didn't have a drawing board to communicate ideas. This is what I use. And so, and I had my own 3 sewing machines.
we were
$20,000 first year on it, sheer. Yeah, everything. Knee roller.
How cool, how
Punch
from the ground up, because to achieve a really 20-hour, 30-hour print that you want to really do this.
But, yeah, just got out of that.
Yeah, I've never.
How are you?
It's coming away. I mean, it's coming along very
So in the process of what we've been doing, they've designed placements for some of those standard programs, so you can actually recruit like Chinese printer.
Yeah. And that's the problem. I want something.
Yes. Right, yeah.
Understand how it works. I can at least about it. But I wanted to see how it works. And then we're building it, and you see that. It's not like T-Row. Looks a little more consistent.
Yeah.
It just needs a little more. So I'm sure it's
It is because what we do is not only do we have the printer, we actually use top of our printer is called filament bed. So it's included, you can put 4 full giant size real top. We have totally protected, dry, that's why it's more than just a printer. Your system goes your job. Yeah, more than one of our machines.
Oh, her stick was there.
Right.
All right, guys, why don't we get this going? Hopefully, can you guys hear me in the back, or do I don't need the microphone, right? You good? My wife tells me I don't. All right, so my name is Joe Dunn. I've been with Onshape almost from the beginning. I started a little after Dave. And Dave and I go way back. I'm originally a SolidWorks employee. I was there for 20 years, so one of the original SolidWorks guys, more or less. In '94 is when I started, I think. Between Dave and I think if I remember, it seemed like we had a wide mix of people. We have some Onshape users. We have some people that haven't used it. I'm going to make a wild guess. Do most of you at least know SolidWorks? Is that a pretty, or another CAD parametric modeling system, which they're all the same when it really comes down to it. So what I think I want to do is I can show you a lot of stuff. We're going to run out of time. That's, and I'm going to keep things simple because that's about the level of, expertise I have. But what I want to do is cover a lot of things. So just forgive me on some of the simple examples. But what I want to concentrate is on kind of what's different about Onshape. What's unique about it. Feel free to ask questions or get more beers or whatever you want. So the very first thing, the thing I always like to explain to people is this doesn't matter much anymore, right? Your computer is there. I could have taken any computer and just shown up. I mean, why I'm bringing computers with me anymore is kind of crazy. And someone was saying that earlier. What I have in Onshape now is you go up, all you need is an internet connection, right? So I just go to any browser. I go to the right.
We need a projector too.
I need a projector, but I didn't do anything. Yeah, I went to sleep.
What have you done?
I broke it.
All right.
It was really hot.
All right.
Here it goes. Here we go.
There
Here we go.
There it is. You need to turn it on.
Okay. First, you turn your projector on. All right. Well, what you can imagine what I was showing you was a browser, but what the point is you just log in, right? There is no download. There is no install. By the way, it goes for the CAM and analysis, the whole App Store. I want to talk a little bit more about the App Store, so don't let me forget. But you just go to this location, right? You hit return. As long as you've got an internet connection, you're good to go. Now, the thing about the reason why I show this is because you really got to think about this. And it took me about a day. My first day at Onshape, You know, I've been using Windows, I've been using desktop apps, I've been using SolidWorks. Yes, it crashes a lot. We're sorry. But you don't realize it's good. It's a great product. Nothing wrong with it. But once you start using Onshape, I still have SolidWorks at home. And as long as I didn't typo, which good. All right, I didn't. What I just did there, I installed, I licensed, I got the current version. I registered my product. That's all you do anywhere, all the time. And it doesn't matter what device. I can do it on my phone. I can do it. I've got a Chromebook over there. If you guys want to see Chromebook, which is probably my favorite platform, you know, they all have their pros and cons, but the hardware itself isn't really the real important factor anymore, like it used to be. You know, I remember getting the best graphics card, water-cooled CPUs, and all that stuff, and it still wouldn't make much difference when you really got down to it. Now, where Onshape is fundamentally different, and I logged into my wrong account, so this is what I get for talking and doing this. So let's do this. We don't have files, okay, and that's a real big difference for us. It's a huge advantage. It's why it's kind of all about the whole point of Onshape, right? So hopefully I did it right. Okay, I installed the software again. All right. Now this is where all my stuff is, right? The first thing you understand is what Onshape has is a document, right? We don't have a part. We don't have an assembly. We don't have drawings. We don't have anything. We have a thing called a document, and that's fundamentally different. And what it, you know, and I can browse. It's a lot like Google Docs. How many of you guys are familiar with Google Docs? A little bit. You know, the paradigm is very similar, right? Wherever I go, my stuff is here. It's all the information. I have a ton of information on the side. Who's worked on it? Who I've shared it with? What kind of I can organize things in folders up here, or I can organize things with labels. You know, we've got all these different organizational tools. You can search, right? And you can do all kinds of very powerful searches. What you never worry about is what drive, what server, what name of this particular drive and server, and what location that stuff was at. Wherever I go, my stuff follows me. I was using it on that laptop or my Chromebook over there. Everything was there. Like, I'm so lazy at home that I have some device in each room because I don't even bring my laptop with me anymore. I have an iPad in my living room. I have an old system in my bedroom. And I got something out in my office. I walk up to different computers now. I just don't worry about going to that one computer with the licensed software to run it there. Let's see. Just an idea for what you do. You click on something to open it, right? This is just a nice, simple assembly. We've got all kinds of techniques for making it as fast as possible. You know, someone asked, like, where does it compare to other systems and everything? And I think, you know, here's what I'm going to say. Dave may cringe or run away, but
He's gone, don't worry.
oh, he's gone. Good. So I'll say it while he's not here. This is going to be faster than any desktop app you use, period. Now, is it today? We're about the same. I use this next to SolidWorks all the time. It's about the same. You know, rough, and it really depends on what you're doing. You know, but most things I do feel exactly the same as my desktop. But the thing is, we architected this for the cloud. That means how many computers do you think I'm using right now? Right? I could be using servers, I should say, whatever you want to call them, racks. It's a cloud. I have unlimited number of computing power and we built this to actually use that. We haven't tapped into all of it at this point. You know, we're just getting the fundamental functionality built out. We have lots and lots of functionality. We need to get this into be, having you said, you may be surfacing, whoever was saying that earlier is, you don't use a lot, but when you need it, right? And that's kind of the world we live in. Just something about our system that people ask a lot of times about, do you have an offline mode? And we don't. But the thing you got to realize is that we're not asking for some super big pipe, it's not a high bandwidth connection. It's really, I use this all the time with one bar tethered to my phone, hiking or something. It works anywhere. And it's because the whole thing is a very elegant implementation. We wanted to build a system. We started from scratch, we had a blank sheet of paper. So we thought, listen, we need to be elegant about it. So just a little peek behind the hood. When I picked that face, okay, what happened was in my browser, I picked something. And then the server didn't really know anything. All we did is we sent a couple bits to the server saying this is the XY location on the screen that I clicked. The server then has all the heavy lifting of, by the way, we use Parasol, we use D-Cube, we use all the same technology as a lot of the products out there like SolidWorks. I don't know if you knew this, but that also means anything that you have in SolidWorks, just opens up in Onshape. We're not converting it actually. The feature information doesn't come over. Your geometry is not a conversion or a neutral file format. We use the same definition. So everything in SolidWorks or Solid Edge or NX or all the other plethora of Parasolid-based products, we just read each other's data natively, essentially. So that's another, think about an advantage. When I clicked on it, what it did is the server did all the heavy lifting. If I pull up my CPU, nothing's really going on. And then the server sent a couple bits back, and then it told the browser what to highlight. So it's this little delicate dance of sending a little bit of data to the server and a little bit back. And so what we're sensitive to, and the only thing that we're really sensitive to, is the speed of light. How fast can we send that little bit of information? How fast can we get it back? So we've actually got another thing that just nobody else in the market's ever done is right now, I mean, I could get into the bowels, but we have locations, I think 10 of them around the world. Wherever you're using Onshape, we figure out what the closest location is, and that's the thing you're talking to. So we've got this very nice system about making sure that, we want minimizing the speed of light, essentially, is what we're trying to do on that. All right. Let's talk about a document. Now, I'm going to create something brand new, okay? Forgive me for doing something simple, but I find this just to be the easiest way to go. So I've created a brand new document. Okay, so what is a document? It's a part. It's an assembly. It's a drawing. Okay, I can create all this stuff. I can create multiple parts. Okay, I can keep creating these tabs. We have these little tabs. Right now, it's all empty, but we navigate by these little tabs, and that's where your stuff is. We call them elements, tabs, whatever you want to call them. But that's where, so you can make one part per document. You can create 100 parts per document. It's probably the analogy is more like a project. And I think if you think of them as projects, that might be a little bit better way to go. A container, a Dropbox folder, a Google Drive, all those are actually exactly what a document is. But it's not a file anymore. It's not an SLD PRT for SolidWorks guys. Now, where we really wanted to make this product fundamentally better than, let's say, SolidWorks, we wanted to improve. Okay, we are a feature-based parametric modeler, right? So we didn't change that. We embraced it. We didn't try to come up with a new modeling paradigm. We think it works really well. So you are creating shapes. You are creating features. I pick a face. I do something on the face. I'll create another shape. I can put dimensions on that. It's the workflow that most engineers are very familiar with today. Okay, you add or remove material with this. Let's add a little material. But everything in our product is simpler. Okay, I don't have I forgot what they call it, protrusion and in SolidWorks. There's two different features: one to add material, one to remove material. That's a comment that we don't do that. I could probably take everything and it's simpler here, right? That's at a minimum, that's the case. Over here is the recipe, right? This is where I'm putting things in the model and doing things. Now, what we started to do different is we said, all right, in SolidWorks, this is how I use the product all the time. I would do multi-body design. I would actually very rarely use assemblies in SolidWorks because they would create more problems than they're worth. You had to use them. You have to use them. But I tried to avoid them because they got the mates blow up. You start to external references. Your files can't be found. Tons of things. We've embraced this idea of what SolidWorks would call multi-body. We just call part modeling. Okay, I have two parts. Let's put a third part in. Let's not do that. I don't know what I'm doing, guys, so forgive me. I just want to get some geometry in. So you can call this whatever you want. And this one I'll remove and I'll do through all. So you can see all these different options for everything. And also for this one, I should also say, cut all the parts. Okay, so there we go. And then, so I got two parts. Okay, not very complicated. But here's a couple things that you might want to think about. How would I do this when you're doing multi-body design in most of the products? Seems like a simple thing. Like that. Okay. We don't have any of those restrictions that typically, that's one fillet I can do one fillet on multiple parts, right? I can shell. Let's just say I want to put a shell in here. Now, every example like that, just like we don't have a separate command, and I guess that doesn't make a lot of sense. So let's do that. And then over here, so all our commands don't care if you have one part or multiple parts. You build things in place. You do parametric design. This is top-down design, right? This is all about top-down design. And this is how you should use Onshape, where you build your parts off of each other. Now, we have the ability to build parts in the assembly as well, and I'll show that to you in a second. But this is kind of a very typical workflow. I would encourage you to build and do things in a single part studio when it makes sense, when you want geometry relations, you want to build a single part history, because we don't give you all the hassle that you might have that you've experienced otherwise. An assembly. Okay, an assembly is really very similar to a part studio. Looks the same, acts the same. I can stick the stuff in here. The only difference between a part studio and an assembly is that there are mates in an assembly. Essentially, there's a few more, but I mean, that's the way I like to think of it. The parts move around, all right? They have relationships, you can put them in, but essentially, the only reason that you typically want to build up the assembly is if you have very large, performance is a big one. If you have a lot of parts, hundreds, thousands of parts, you probably want to make assemblies, multiple parts to do that you put together in assembly. But what we do here is, let me throw this together. I'm going to put one mate in here. Okay, so I've added a mate. Now, in SolidWorks, it doesn't. In any other CAD system, this would have taken 2 mates to do. So one thing that we've done, just similarly, or another way that we've tried to improve things, is that we wanted to have fewer mates. Let's just put it that way. And so, and because of that, one of the benefits is that, think about, I don't think I ever had an assembly where I didn't have the mates blowing up, right? And the errors of mates not regenerated and stuff. We don't really have that. And our mates are actually, they have some pretty cool stuff to them. For instance, that's a Revolute mate. Later on, I decided it's not going to make any sense again. You're going to hear me say that a lot, I guess. But in fact, if we just play it, you can kind of see I can change it at any time. So I don't have to delete it and put it back in. A mate itself knows it can be anything. I just have to tell it, are you a cylindrical mate, a Revolute mate, a pin slot? Doesn't matter, because they're all just what we do is we have 2 coordinate systems that go together, and it's a relationship. It's a degrees of freedom between those 2 coordinate systems, and that's how our mates work. It's fun, So it's a very common way of looking at it in the kinematics world. If any of you have done mechanism designs or using kinematics applications, they all think this way in the past, and that's the way we do it as well. We let you change and modify your mates. Let me go to my slide for a second. Oh, there is no save button. Okay, so if I kill this, I pull the plug, I just killed the browser. I didn't save. Right? What's going to happen? I could pull the power and go somewhere else and hop onto another computer. This is that no crashing part. Sorry. So let me log back in. And there's that document that I was in. You don't lose any of it, right? You never lose anything. You go right back to exactly where you were. I call it the pucker factor. How many of you have used your desktop application and been using it for hours or the whole day and you realize you didn't hit save? And then you're worried because save sometimes crashes, right? So you're in that quandary, what do I do? And so, screenshots or something like that. And yeah, no, I've done it, so we don't need it. We cache everything. We remember everything. By the way, the undo. Notice I have an undo. That undo doesn't go away. We actually have a persistent undo. In fact, if I go look at it, let's just take a look at it. Not only do I have the history of the model with the feature manager with the features, right? The feature list. We have extrudes, the sketches and the design intent, you want to call it. Our undo stack is separate. It's built into our system as well. So the undo is always there and persistent as well. So you've actually got kind of like 2 different ways of working with your history, the undo and with the features in Onshape. So these are always something you can go back to a particular state. You can restore it if you want to. Typically what you need to do is, let's just say this is the most magical state of the model. It's a milestone. I need to share it with all my colleagues, or I want to do something. What you can do is, if you do want to capture a state or do it a snapshot in time, okay, you create a version. So it's not a save. You can call it a save if you want, but it's really just a snapshot saying, I want that there, and I want to be able to go back to that at some point in time. I can start adding more geometry in here just to show add it for another version, right? And this is a very typical way of kind of, when you hit certain milestones, if you want to, you have a mechanism to I've just done V1 and V2, and that's what this thing is showing here. You can see that It's giving me those particular states of my model. Those are called, they're immutable. They're there forever. You can never modify a version. Those are there, and those are, you can share them, other people can see them. You can branch off of those and create a new derivation or a copy, actually. If I want to go back to this one and say, you know, what I really want to do is I want to create an alternate study, or maybe I just want to work with a colleague and I want him to work with the version before that hole is there. So now I have two branches, one with the hole, one without. And both users could be working in modifying this thing at the same time, and they both are actually working on separate tracks. It would be equivalent, a branch for us is very similar in SolidWorks or Pro E or any other one of copying the whole file. That's really the only analogy that they have. The thing is, we can bring our versions back together and merge them, and it's a true semantic feature merge, where that's why we have that undo list. Our undos, our text, you can actually, you make changes on both. They can go on for forever or for several days or for a certain period of time, and then the users can bring them back together if that's something that you want to do. And that's, again, we started from the ground up to think about these types of things, all about feature-based modeling. I didn't show this. Here's another interesting thing. I'm just opening multiple tabs in Onshape, or in the browser, I should say, not Onshape. And then I got to find it. See, I'm a Windows guy. You can tell. It's useful, I can say that. Okay, so I've got these three windows in the browser open, and you notice that there's the little green J and the blue J, and then there's a purple one here. I'm logged in 3 times. I'm actually, the only way to do this anywhere else, I'd have to have 3 computers with 3 installations of desktop software and run 3 separate computers to do the same thing. And forget about opening up the same model at the same time. I've got 3 instances of a separate, they're not hitting the CPU. I can do things in all 3 of these and work at the same time. I can open up different models. So one of the things you can do in Onshape, again, it's local hardware. You're not constrained to that one CPU. You know, I'm not sure how many people can do 4 or 5 things at once, but the hardware is not holding you back anymore. The software is not holding you back on that. Now, what you can do that's really interesting is that 2 users, this is simultaneous users working in the same branch. We're all in the same branch right now. And if I make a modification to one, let me just try to make this so you can see both. All right. I'll go in and take that first one and make it bigger. Now, what this other guy sees is, you notice that this user is seeing that I'm over here, I'm making a modification, right? It's saying, it shows me the symbol, a lot like Google Docs, but it's showing me that's the guy, that guy's modifying it. I know he's modifying it. Now, I haven't finished over here. I don't know, I guess I'm the green guy. Just because I'm logged in the same user is not any different than if I was in China, a different user. It's the same thing. It's just, this is the easiest way for me to do it. But when I do this, I say, okay, everyone sees the same thing. We don't have copies, right? There is no such thing as a copy. This is why you're going to see some PDM, some release management in a second. And the fact that we don't have, everybody's always seeing a single source of truth, right? So no one ever has to do a checkout, modify it locally. I mean, how many of you guys use PDM before I even start talking about that? Right. So there's no such thing as someone checking it out, so only that person can modify it, and so no one else can see it until he checks it back in. You can control it with versions. If you have a state that you don't want someone to modify, make a version of it. But what you don't have to worry about is ever not knowing what someone's doing, or accidentally them checking it out, or all the other problems you have with moving those files around. Everybody's looking at the single source of truth. Okay, let me look at my presentation. All right, I skipped about 20,000 things. That's just kind of the basics of Onshape before I start talking about some of the more powerful new stuff. So you guys got any questions on some basic stuff, or should I move on to the Parametric 2.0 new things? Yes?
The undo on the branching, once it comes back together, continues on to the new branch has the same undo.
It does, yeah. I mean, it's using undo, and it's truly saying, by the way, reorder, new features, old features, delete. If we look and say, what's the difference from a feature perspective? You know, and multiple users could have been doing stuff, and we say, Joe did this, Dave did this, and we really do a really excellent job. I mean, this is what we thought of. And we started with a blank sheet of paper and really thought about how we can make this work better. That's all. You know, it's not parametric modeling is not a new concept, but what we're trying to do is make it modern and improved. So let's talk about sheet metal. Someone asked about sheet metal. Let's.
One quick thing, when you
Yeah.
restore, that's just another thing that's put on top.
Yeah,
So you
keep
can
going.
undo, you can restore from just before that restore, everything is always going forward, even when you go back.
What if you're really embarrassed about one of the features you made, you want to delete it forever?
Yes, there.
Well,
You can delete.
you can delete the doc. I mean,
Another thing you can do actually is you can copy the document to another, you can delete the feature, copy the document to another document, it won't copy the deleted stuff, it will just start from where you are now.
So one more question on the other.
Yeah, please, go.
So the ability to, I'll get to it.
Come back, don't worry. You'll hear me do that many times.
Can I ask any advantage to a touchscreen system with Onshape?
Well, we're in the browser, so you have to ask, do you like using your fingers on there? I mean, we're not doing anything special with touch screen. Realize that on Android and on iOS, we do touch really well. Have you tried those? So it's not touch on a laptop, but it's touch on. You should try it if you haven't, because when you're using the mobile apps, you actually download a little app, right? It's in the iTunes store, you download it, and on Android, on Google Play, you download it. And all that is, by the way, what's so cool about it, it's just a small thing you're downloading, but it's all about touch. The problem with browsers is the browser itself doesn't quite deal well with touch, or it's okay with it. By the way, we have a Microsoft guy right here, and he could talk to you all about maybe advances in the browser for touch and everything. But where we did really look at fingers, I think we even do 3. Did we 3 fingers? Yeah. We have an app that sits on top of the browser on the mobile app where we really give you all kinds, we have patents on it, of really using fingers well. And that's why we did it, right? Yes.
So on Mac, how many people use a touchpad versus using an external mouse?
I use a mouse. I hate touchpad with a white hot passion. Yeah.
What about a Spaceball on Navigator?
These are all personal preferences. They all work. Yeah. Yeah, we actually have a driver for space for the connection. So you can use that, yes. And it's like 50-50. It's a religion, right? If people like it or don't, right? So, yeah.
Okay.
Yes.
I've got if I'm working for a personal client on my own version of SolidWorks, and we finish the project, and I've got all the files on my computer, but they're really the client's files because I've been doing it for him. At the end of the project, even whether he does or does not have SolidWorks, I can create a file of the entire assembly we've been working on. I can give it to him on a flash drive so that he has everything that.
Well, no. Well, you could.
Well, wait,
oh, sorry.
He now has everything that I've done for him. If I do a project on Onshape for a client, how does the client get?
So I miss. Let me tell me if I answer your question. I actually skipped one of the most important parts of our product, the share button. Okay, and so the way you do it is you share with them. You give them permission to see your data. Okay, or you can make them owner. You can give them owner. You can make them the owner. It doesn't matter if they have an account with Onshape or not. That we have a free version. Worst case, we have a free version. The reason we have a free version is there's a lot of reasons, but the way I like to explain it is we have a free version because I want you to be able to share with anybody in the world. I don't care, any email address, will work. And if they don't have an account, we give them a message saying, create a username and password, then they can open up your model, right? And yes.
And you can transfer ownership as well. So if they want you not to have access anymore, you can transfer ownership to them in their free account, and they can have ownership and block you out. So all of that is possible.
Yeah, you just have so much more control right now. And take the share permissions. You can see we have all kinds of granularity. Do I want them to edit? Do I want them to view? You can share to groups of people. You can make it public. I don't know if you guys have seen the public area, but that's where, if you're a free user, your models have to be in public. That's the only, by the way, free users get everything. We don't hold back functionality. They get everything. But their models can't be private.
How would that work in the case of you're transferring over to?
Actually,
so what is?
They stay private, but they can't edit them.
Yeah.
They can only edit public documents.
Yeah, we wouldn't make them go away or make them public. That would be, listen, security is ridiculous. We're ridiculously serious about privacy and security. I don't think you can do it better than we've done it, but yeah.
So if you start off on a free account and you're developing a public project, they say you have to, and you transfer owner to somebody on pro, what happens is it's still.
Well, then they could make it private if they want to, but it had already been public.
Out there, somebody could have grabbed a copy of it. But,
yeah.
But still, maybe if you just were starting it up and then transfer it over, now they can share it back out with you and you can work. Well, you can't work on.
Well, I mean, I realize that these are all the public models. In fact, I really love to do this one. I do sort by modified. So these are all people that I don't know anybody here, mostly probably, but what I do know is that if you look at the timestamp, I can keep scrolling. Every minute there's hundreds of models being created. I mean, that's how many people are creating stuff here. I can't modify these, but I can look at them. I can click on it and look at it. And if I want to, I can make a copy of it. But I can't modify their document. I just see it. But yeah, I mean,
if he makes a copy of it, he has private. If he's a pro, he can make his copy private and do whatever he wants.
Right. It's a derivation, right? All right. Sheet metal. So we've done something with sheet metal. It's just sheet metal like you've probably seen in many products, but what we've done is simultaneous editing sheet metal. And what that means, you go over to your button here. I'm going to create a sheet metal part. There's a lot of ways to do it. You can do a flange at a time. You can create all kinds of sheet metal features, but this is my favorite, is just to convert the model, right? And if I take this little fly out and pull it out, again, fundamental, so many things are going on here. It's just lots of cool stuff. First of all, you can modify this, and then you can modify this, everything you can see at the same time, right? If I start doing things, okay, like I need to put some bends. That probably should be a bend. That should be a bend. You notice how these things start to come together? What we don't do is what I don't like about other sheet metal applications that I've used is that at some point, at some point when you do something and it just doesn't work, right? You have a sheet metal part just fails. And they always want you to, it's always got to be perfect essentially, right? And for us, if you want to be detached, we let you do it, we let you see it, we let you evolve as you model it, right? Let me see, I'm not the best sheet metal guy. Let's see if I can figure this out. So here we go, that one and that one. Will that get us there? All right, well, it's giving me all my geometry for whatever I tell it to. And what I'm doing, I'm putting bend. That's true. Which one? Someone see where I should put a bend?
Oh, yeah. That little
this guy? All right. Okay, we're getting closer. But, oh yeah, I want to exclude some faces. I really don't want one there, maybe, and maybe I don't want one there. So, it's what sheet metal does is it lets you. It kind of lets you
change the bend radii as you put them in there.
Yes, it does let you do that as well.
Right now, as you're doing it in here, in this converter.
Yeah, right there. Like if this particular one, I want to make it 0.125. It changed 125. Let's see which one that is. You know what, guys? This is what I get for talking and not paying attention. So
remember, there's no save function.
Yes, very true.
I couldn't change it, so I did a bend change later on in the feature tree. Well,
you're in sheet metal mode. All right, let's figure this out. All right, so first of all, I don't want a face. Let's just make it simple. I'm gonna take these guys. I don't want one. Faces to exclude. I'll get rid of that one and get rid of that one. Okay. And let's just get rid of that one because this will make my life even easier, less stuff to pick. Okay. And then I want to bend there. I want to bend, don't need to bend there. I want to, see, this is why I don't do sheet metal. You can see why. All right. Okay, we're getting closer. That one, that one, that one. What else? I guess that will work. Will that work? No. All right, look, guys, I'm massacring this, and I so apologize. But
the first corner you did,
yeah, I mean, this is my fault, not the software's fault. It's doing. The thing is, it lets me do it. It's saying, okay, these things can do. These would not be attached. Maybe that's what I wanted, but the point is, I can't. The other thing you can do that, in the sake of time, I'm not going to get into is you can build a sheet metal part off a sheet metal part off a sheet metal part, which you can't do with the other systems, right? So we let you stack them up because it's all one part studio. We don't care. Make as many sheet metal parts as you want. All right.
Can you do slots and tabs so that when you put your single pieces in, they're going to fit into a slot or a tab?
Slots or tabs?
A little cutout in the sheet metal where if you're going to weld, those other small
Yeah, so we
pieces-
have tons. We can go into detail. We'll take a look at detail. Pull it up. Yeah. Okay, configurations. Is that a good one to do? All right, let's do configurations. How many of you guys know what configurations are? Raise your hands if you know. Okay. So I'm going to create something from scratch again. And in this case, let's just make a washer because it's just very visual. Okay, this and that. And I'll throw a couple dimensions on there. That 10. That 5. Okay. Now, first thing you do is go over the flyout, and what you'll notice, I want to configure the part. Now, what I'm going to do is I'm going to make a small, medium, and large. Okay, now what I'm going to do is I'm going to say, okay, what do I want to configure? I want to configure that, and I want to configure that. Okay, what I've just done is no different than any configurator out there, right? Table-driven approach, if you want to call it that. You know, each row, I have a small, medium, large. I just got to set their size. So let's make this, I'll leave that the same and make this 15, 5, that 10. Just making them a little bigger, right? So let's make that 20, make that 15. Okay, so, and then over here, you'll see that it lets me choose it. And it's going to do what you would expect. That one was the same. I didn't change it from default, but this one's a little bit different. That one's a little bit different, okay? Very different, okay, configs. Now, the thing that we let you do is instead of having to have each config per row, what if, a lot of times configurations, you might have thousands of them, hundreds, thousands, tens of thousands, like the combinations of things that you might want to do. We don't require you to go in there and generate each one at a time. I can go down here and say, I want to actually allow them to enter a user-defined value. Okay, so this variable down here is called height. And what I'm going to do is copy that. And then I'm going to take my the height of this washer. I'm going to paste it. The right command. Okay. So now, if you notice that I have another option here, I have large, and I also have a value that I can specify anything I want. But let's do one more thing too. Let's say I'm going to put chamfer on this thing. Now with the chamfer, I want to give the users the option to turn that on and off too. So we'll go down here and do checkbox. And I'll just call it champ. Okay, and then I'm going to configure this feature here. I'm going to say on this feature, it can be suppressed. Okay, so when it's not checked, it's unsuppressed. I may have it backwards. So the way it works now is you have all these variables. So let's put these in the assembly. Let's reuse these. So what I want to do is I'm going to insert that fastener. I'm going to say I want to put the small one in. I want to specify a height, and I don't want a chamfer. And I probably my logic might have gotten it opposite, but yeah. All right, I did get it right. Yeah. Okay, and then I'll put it in the medium, and I'll put the chamfer on, and this one should be 5. I'll generate that. Okay, and et cetera, et cetera. Basically, I have an infinite number of variations here that are configurations. Okay, this is what we built our system to do from the ground up. I mean, it looks really simple, but think about what I've shown. I've got the ability to do all the logic, nothing special. It's just built into our system, right? Configurations, nobody does it like we do. I mean, it rocks. And that's, you can't do that in other systems I'm aware of, period, right? Yes?
If you go back into the original, not file, the original document to make a change to that shape, it appears in all the other documents that are using it?
Yeah, if you modify the config, yes. So, yes, it does.
You have to update the part of the assembly if you're.
Remember, we're doing versions though, so everything in the assembly. We'll get into that in a second. So we don't ripple changes willy-nilly through everything. So you're referencing a version when you put it in there. So when you make changes, you change the new version above, and then you can tell everything to update. You can update the versions to the next one. So you control that essentially. Okay, go back to my reminder here. What is next? So standard parts. These all kind of go hand in hand a little bit. So how many of you guys know Toolbox, SolidWorks? So we've added the ability to have kind of standard components, nuts, bolts, washers, all that kind of stuff. You know, here's a nice assembly that needs some things. If I go into insert, it's, you know, we have 3 things that you can insert or look at. You can use the current document, insert stuff. You can look at other documents and then insert other things from other documents into this document, or I can go to the standard component stuff. And here I want to just pick nuts, bolts, and washers, hex, yep, all this stuff, just different options for things. You know, this is equivalent to Toolbox, right? And it's lets you measure things, so I don't have to remember the size or shapes of things. I give it some values. I can insert it just to, you know, see what it's, you know, I can manually stick it in a certain location if I want to, one at a time. But one of the cooler things we can do is I can just pick this face and say insert, and it'll stick them all into the right location. Right? Now, it gets a lot better than that because, first of all, right now, if you share this model with anybody else, they'll be able to read it too. Because this is built off of our configurations. I show configurations first because our standard components is actually using configuration technology. And the thing is that the entire world, or your entire company anyway, is looking at the same definition. I don't know if you know, it's that file problem again. I used to get assemblies all the time from people, and the Toolbox parts don't open because those are on the local disks. Each company copies them and installs the libraries locally, and they have all these files. They have, you know, one socket head screw's probably got 100 or 1,000 of them throughout the company, and each one's referencing them. And unless you generated that configuration of that file, you can't open that model up. It's just a mess. And you just don't have that problem here. We're actually having a master catalog that everybody references, right? And we're just scratching the surface here, guys. This means the entire world can reference one true master definition of a socket head screw. Now, you can add your own company standards. You can add your own properties and definitions to them as well, so you're not stuck with it. So we built this in the right way. I don't know if you want to add anything else to it, but I'll leave it alone. Okay.
One question.
Oh, sorry.
So this may be a religious topic, but any possibility of integration with external third-party systems like with MasterCard?
Oh yes. So you've just hit my yes. So okay. This is Onshape is a platform as much as a CAD tool. Suffice to say that this seems like a really good solution for those guys, doesn't it? Yes.
Okay, so you're not the issue.
Well, I mean, we can only do so much at a time, but it's just expect to see this.
It's a two-way.
Yeah.
To be a platform, people have to choose to use a platform.
Yeah, but I think that you're going to see a lot.
Platform. Some people choose to use it.
I'll show you just a couple things in case you didn't know what these do, just in case. I can put a washer in. Hopefully it's the right size. If I insert it, oops, didn't do it the right way. Let me undo it. I need to say nearest to selection. I need to select it and do nearest to selection. And what that's going to do is it bumps them up, right? These little 2 things, I actually didn't, until someone else showed me, I didn't quite know what they did exactly. So, but they're really slick where you pick it and then you can keep doing stacks, right? You can put in washers, nuts, bolts, and wherever you select it, it's going to put them in the right spot. So, I mean, it really is just done really well.
That bumped it up and it collected all the mates too, so that the washer got put in, the screw head bumped up on the surface.
Okay, so that's standard components. Now, we're kind of showing all this stuff in that it's a, you know, these are all just kind of the things I think that we really drastically improved over standard parametric, you know, how parametric modeling works today. Let's talk about one more thing, and then I'm going to show feature script. How are we doing on time? I know I'm
20 minutes.
20 minutes. All right.
And then we'll do questions.
Let's do feature script because I want to show. Well, you guys tell me. We're going to choose. I'll never get through everything. We can come in. Well, I'll show you all the stuff you want, you know, one-on-one. But we can do feature script or in context design next. We want in context. Okay. Now, so you can do part modeling where you can do multi-part design, right? We just build parts off of each other, single history in a part studio, no problem, right? That works, no problem. I have a simple hinge. I'm using this again because this is a very visual example. If we look at the assembly, you can see how it moves. So let's animate this thing. it's a hinge, right? It's a door hinge. So there it is, no mystery. It's just mates, parts in the assembly, voila. Now, since I have mates, what if I need to build parts in the context of the assembly? That is, this thing has multiple positions. And let's just say, for the sake of argument, I'm going to make a bit of a contrived model, but it's very visual in that I need to build things, but this is what you can't do in other systems. I can't build it so that some of the geometry is built in one spot and some of it's built in a different spot, like a start and a stop, right? That's a very typical thing. So you use this command here. It says create parts in the context of the assembly. So you just have to give it a frame of reference. Okay, now I'm modeling in it. It's going to see all ghosted. So we're bringing it in. I'm in a part studio again, and I'm bringing in the geometry I'm referencing. So we're giving you some visual cues that you're adding geometry, in the context of the assembly. And then I'm just going to draw one here and draw one up here. And then what I'm going to do is let's first of all take these two and glue them together and say those are coincident with each other. And same thing here, because I wasn't paying attention to my references. So boom. Okay. Now, I'm only doing this so that I got I have some geometry guts. That I'll create a simple little shape here. Let's offset it. And cap the ends just so that I have a platform. Here and there. Okay. Okay, so depth. The point is, this part is built, call it part one, fine. Built in the context of the assembly at that position. Okay. Now, I'm going to do something. What we don't do is it doesn't update, right? That doesn't change. That's the first nice thing. Rebuild all you want. It's built at that position in the assembly. It knows the context of that particular spot. But let's just say that I know that the full articulation here, at this point, I need to build another feature because that's going to be the stop of this thing. Okay, so let's go in there and by the way, I can update it. I should say there is the ability, just go back here. Let's just say I've updated it just a little bit. Okay, you can go in there. You can see we have that little symbol there. Sorry, over there. And you can say update if you want. It's called, you can update the context. Boom. And that's saying at one, do update. That's equivalent to the rebuild button in what you're probably seen in other projects, right? But you controlled exactly when it updates. But let's go.
So the key thing here,
yeah,
you have used the context in older systems. In older systems, that could update anytime. Anytime that assembly regenerates, it's going to update. So move things around.
Can't control
it. And your parts will change shape. Usually, you don't want that. In our system, it doesn't happen unless you tell it to. And that's what Jeremy showed.
Now I'm going to do another part. And let's pick that, sketch on that. And again, let's do, I just want some geometry that's touching this let's just call it a stop for the sake of argument. Perpendicular. Okay. And then, same kind of doohickey here. Now, offset that. Because the cool part is about to happen. All right, I'll make this a little smaller. Same thing though, I'll give it a symmetric. Okay, so now I have a part, okay, and it's stopped at this point, okay, and it's at this point. But here's the deal, I can move this a little bit like this. Not both of them are going to be locked in place, but I don't have to update. I can update each context separately. I'm sorry, let me make this full screen. I should have done that. So if you notice, I can say on this part, I now have two contexts. I could have named these, by the way, if I wasn't so sloppy. I could have said start, stop, and given you should name them. It's bad practice what I did. But I've taken this assembly and said, you know what, the stop is really right there, but I don't want this to update. I only want that feature to update. So that's my second context. So I'm going to say update that context. Voila. Okay. Now maybe this feature is really a little bit different than that. So some design change means that change. Now that context has changed. So you see how you just have complete control now over each individual context here. So it's assembly, top-down design in the assembly with a lot more control. And that's, I hope, at least visually clear. Yes?
Just a little up here from the back here. Are the two L-shaped pieces that you built in context the same part?
Yeah, I put them all in the same part. So each feature basically, each sketch actually has that reference. So each reference is a context essentially, right? So I have two references.
So if you wanted them to all be in the same context, what you would have just done was you would have edited in the first context.
And I could have done that. Yeah, I could have edited that context and then put those features in. I purposely said it's a new position. I want a new context. Yeah. Who came up with that name?
Edited context?
Context, yeah. You did, right?
No.
Oh, all right. Okay. Okay. Let's talk about release management, data management. That's the other big topic of things that we've done. Now, my experience, let me find the right slide here. My experience with data management, a lot of you guys raised your hand, which this should be really good. Is that you don't want to use it, it's hard to use, it's a necessary evil, it serves a purpose, but I avoid it as much as I could, because it's hard. I mean, it's a hard topic in general. We have branching and versioning, right? Versions are allowing you to capture anything at a certain point in time. But what we've done is we've added revision management to Onshape. And it's really just done well. And you'll see in a second. Because I think what you'll find is people will use it. Because it's simple. And it's completely integrated into our product. Throughout everything I've done, I could have been using release management as part of that. If I was context, everything I could have managed that way if I wanted to. And to start off with, and I think for that reason alone, people are going to use it, and they're going to use it a lot. But if you just go into your account settings, each company has their own standards. So what we've done is we've given some simple workflow. You have a reject and a accept or obsolete workflow for who signs off. It's a lot like a version, only it's a more formal process, right? Versions, you can capture the immutable state anytime you want, but when you have a formal process where you need more people to interact, perhaps, that's what the release does. We've added some numbering, automatic numbering schemes. You have the ability to pick how you want your part numbers to be numbered. You can use manual. You don't have to use these. These are optional as far as the numbering schemes. You have a bunch of check boxes for if the part has an error, don't do it. Lots of little options. And this is going to expand over time. You're going to see probably more stuff, but little rules for when you can do and when you can't.
So these are your company rules.
The company rules. Thank you. So let me go in and try to find a good example of release manager. I like this model. I just think it's got a little bit of everything in it. So it's a carburetor throttle. Okay. Now, what I have is a part. I've got these two things, which are configurations. By the way, configurations are going to be managed. I can change the configuration, and one could be big and one could be small, short, whatever. So this part has parts that are built singly and added to the assembly, has some configurations. I have standard components, so there's a bunch of nuts, bolts, and washers from the standard components. And I have this little thing called these other parts that I've brought in from other models that are referencing the release. So they're actually saying, I want this specific release in the document. Now, the reason why I point all that out is it's just kind of covering a lot of different things in Onshape. And let's just say that this has been modeled. If I look at my version graph, nothing's been done yet. But let's just say, for the sake of argument, this is now at a state where I want to go through a release process and I want some people to do some things. There's about 3 or 4 different ways to get to it. I typically do this, but you hit the release button. It's really that simple. Let's give this one a better name. Okay, so it automatically understands, first of all, that these parts, one of my parts already was at Rev A, so it be bumped to Rev B. Okay, it knows that the 2 parts that were referenced, that were already released, I'm referencing the actual release of those parts. Those are not going to be affected. By the way, this is called a release package. Okay, so I can I can add more stuff to this if I want to add parts and assemblies and add more things to it. I can do that. I can use that numbering scheme where I can go back and say just auto part number those, because anything that makes my life easier I like. So that's using an auto numbering scheme in there.
Guaranteed, because it's a database.
Yeah.
That those part numbers will be unique.
It made me change this one because it already had one. That's exactly why I had to change that one.
So basically, you can never use a release number that's already produced before.
Mm.
Can you add other types of documents to
Yeah,
this?
anything.
Just
You
like
could,
Word documents? or-
everything in your document, Word, PDFs, images, whatever, all that is part of this. You can add those.
Parts, assemblies, drawings, configurations of parts, and any file that you've uploaded, you can release.
It's so automatic though, I think, in that it understands from the ground up all the things that we're doing. So if I say submit, I've now launched, and I could have put, sorry, I put my name on there, but I put Dave, I could have put other sign-offs in there, and everyone's now going to get, if we go look at the version graph, it's going to say ECO, it'll say pending in a second, just give it a second to refresh. It goes into a certain state, there we go. So it says pending, it's a little triangle now instead of a dot, right? The dots are versions, triangles are a lot like versions, but they're a little bit different, they're revisions. So it says that now I have a revision it's pending, it hasn't been approved yet. So we're visually, I'm giving you an indication.
The fact that the triangle's open means the release is open.
Now I get my email just dinged. I also get a notice here, so I could, take my pick on which way I want to go. But here's the release package again. So I'm the guy. I sent it to myself, but I can approve it, and I can either reject it or I can say, "Yep, it's good to go, release." And all the sign-offs would do that as well. Honestly, it doesn't get any harder than that. Now, the thing is it's done. You're going to see it. They're all released. They're all good. And everywhere in our product, you'll set in the version now, it shows it's released, it's a solid triangle. And having said all that, everything we do honors this stuff. So if I go in and say, you know what I really want to do is I want to insert some more parts, just to kind of give you an idea for how thorough this was integrated into our system. Throttle, I got a fuel injector. I want to actually specify the specific release of this injector. So what I'm saying is, I'm not doing a version, I'm not doing a workspace, I'm actually saying put in the actual release version. I'm enforcing that. So you'll see down here in this fuel injector that I just inserted, it's showing down there that I've inserted the specific release. So you're controlling exactly what's in what version or what release each part is in your assembly with complete control.
So you can say just that easily, like I'm only doing assembly here, I'm not doing any modeling, and I'm only using predefined parts, so I only want to look at released parts when I fill out my assembly. And we can filter and only see released parts.
Are there any questions on that? I mean, I kind of blew through that pretty quickly, but
The assumption is that you have to have everything in there when you actually do the release package, including drawings.
you should have drawings. Yeah, you should have drawings.
You can do it in.
You can do one part at a time. You can do one config.
Yeah, you shouldn't think of the release package as, that's it. Like, now you just have a bunch of stuff that was released that happens to release in that package. If you forgot a drawing, you just do another release package and say this drawing too, and that's it.
Anybody have questions?
Joey, should switch gears about 10 minutes. So if you want to talk about.
I got 10 more minutes?
Yeah, you can.
Okay, let's talk about feature script. All right.
Joe, I assume you could then share that release package with a supplier at whatever division level you choose.
Sharing at a revision level. You can share a document right now. We don't let you share revision.
You can basically share it from the standpoint of you can share a document. You can put that in its own document and share that document.
Yeah,
Right.
right. My guess is that's a very natural thing to come. I mean, those are very logical, right? But yes.
In the settings that you showed earlier from setting up those workflows and controlling all that stuff, presumably that's the user that sets that all up. Can you lock that down from an administrator also?
Yeah, it's actually an admin for the company.
Yeah, it's a company-wide setting, so everyone can get one guy in your company, whoever's the admin.
Did you say show simultaneous bomb?
I didn't. I'll show it quick. Right here, simultaneous bomb. Well, it's simple and clear. You didn't have to create a drawing, and everything insert it. You got lots of options. All the revision stuff is there, as you notice. I can change it to structured or flatten. Those are two options right now. Okay, but it's a native thing. I can modify it. What can I do? I can modify here and give it that great name, and that's modifying the property. So wherever you make the changes, everything you do, if I reorder, I think that's a good one to show. So let's take this and reorder this down here. Let's move this up. Okay, reorders, and it's just like sheet metal, right? The two things are in sync.
Yeah. The BOM was built as he built the assembly. So those two red things that he put in there are in the BOM. He didn't have to put them in the BOM. He didn't have to build the BOM. Anything that he edits in the BOM is edited in the physical assembly. Anything he edits in the physical assembly is reflected in the BOM.
How many of you guys know about feature script? I also have CAM and analysis. By the way, so yeah, well, it's running out of time.
Why don't you just go to the website?
We'll do two. So all right. So feature script. Just you guys got to check out feature script. It's one of those things from the ground up. What is so unique about Onshape is feature script, because that is our source code language. When you use a feature script, you're not using a macro or a script or the API. You're using core Onshape capability. It's just that if we don't write it, someone else can write it. We open source Onshape. Our feature definition, all of our features, we distributed the source code for people to take our extrude command. They can modify it if they want to, or add new ones and do some cool stuff. Now, lots of ways to find out about feature script. They show up here. I have I have these little commands here that I've shown up, but I can add another feature script feature by going in here and searching for it. And there's two categories that are an easy way to find it. If we go to the ones that we supply, here's some different features that we're kind of giving you. I think the extend surface is right here. Whoever mentioned that earlier is right there. Now let's just try. There's a spline that I like to use. I'm going to use one, and then we'll come back to this in a second. Always seeing them is always. So I want to use the spline. Now I can use I can add this to my toolbar, which is what I just did. It says it's now there. So from that, and I referenced it. So if anyone modifies that feature, the author of that feature script feature decides to make some changes, I could also get those changes in my feature if I want to.
So it's kind of just like what you showed before within context. It won't change. He'll be using the definition that he originally referenced, but you can always choose to update it later. But it's a choice.
No, and I did add the wrong one. See, I can't read this. My glasses are dirty. I'm going to the eye doctor next. Very spine. There we go. All right. Spine, not spline. Okay. Not that one. There we go. So here's just an example. I found a spine that's part of, the shaft. Look, I put gears. I can put all kinds of stuff on here. But this is just a simple one, right? It's not a big deal. But if you notice how simple that is, I just popped it in and put the spines on there. And it's a feature right here. And if I want to go look at this thing, I can say, you know what? I really wanted 6 of them instead of 4 of them. It's got all the rules. However smart someone made this, it has that behavior. It just saved me a lot of little grunt work, right? But if I open this model up on my phone, if I open it up anywhere, editing and creation are exactly the same thing. It works on any device. I mean, this is native Onshape, so it's not something that you got to compile and. Yeah. Yeah. So there's a ton that you can do, and if I have, what you can do is you can use feature script and configurations together, and they actually understand each other. So we can do some very interesting automation stuff there. But suffice to say that feature script is one of those things, and if you want to just learn more about it, you go to learn about feature script. We've got all these examples that you can take a look at and find out more about. There's the extend surface. If I open it, if you open up one of these documents, these are all their individual documents. It gives you a little indication of what they do. This is the open up one of these documents. These are all their individual documents. It gives you a little indication of what they do. This is the actual code. So that's how it's written. So the source code is usually available depending if you're interested. You can just use them, or you can write them, or look at them, share them with other people. It really is a whole nother world as far as automating anything in Onshape. You can automate, right? If you can build it in Onshape, you typically can make it in feature script. That's right.
And is that C++ or?
It's feature script.
Yeah, it's a special domain-specific language. So it's a new language, and it's got everything. It's got parametric modeling built into it. So all things like parametric queries, so when you pick an edge, it will remember that edge even if you go back and change things to change that edge, like previous in the history. Like all that stuff is built in. So built into the language. Onshape's
an interpreter, really, when you get down to it. I mean, so Onshape is feature script exists. Onshape doesn't really exist in some ways. You know, so you're really running an interpreter on top of feature script when you use it. So yeah.
So the key thing here, the key points of this is feature script is a language we developed. It's a domain-specific language to build features that you find in a feature list. We use it for all of our features. We made that code public. All that code is completely public. And we made the language public, so you can define your own features, and when you define your own feature, it's a first-class citizen like any of our features. It works exactly the same way. You can share it with other people by making the document which is defined public, or you can limit it to just you by not sharing it, by making a private document, or you can share it with your friends or your company and only they will see it. So the same way you share documents is the same way you share feature script.
Okay. Wow.
The definition of that feature is in the document.
It is, yes. Well, you reference it. Yeah, it's in the document. The
So
source
once you've
code is.
included it, if they unshare, we don't lose it.
It's the same version control.
Yep,
or
it's just native.
and all that. Template.
Yeah.
But in fact, it's just another tab in a document.
So my responsibility on Onshape is nothing that I showed you today. It's this. So we have an app store. Okay. So one of the things you asked about analysis, CAM, rendering. Okay. Our approach was to really mimic what we're focused on mechanical design, right? And we're not doing we're not doing an analysis product. We're not doing our own CAM product. We're partnering with people to do that. And we want to let you guys have direct access to it. So unlike or similar to, it's exactly like getting an app on your phone. It is literally that simple. You go and you can go to the simulation category. These are all the applications that are available to you today. You could go to, I heard Power Surface. Power Surface is right here for if you're interested in finding out how this product works, for creating some complex stylized shapes. Okay, to use these applications is really, really easy. You just simply, you pick one button and you subscribe to it. It knows who I am, so it sees that I've already subscribed to this app, but it's a single button. Whenever you use these apps, they also follow you. Wherever you log in, your apps are also with you. So it is a really slick, simple way to find and try apps if you want, or purchase them, hopefully. And I can try a few of these. If you want to see, this is our CAM application. There's a few that I would recommend. The one thing about the App Store is we have some applications that are probably, it's an open marketplace. Anybody can put them in there. So come talk to me, because at this point we have awesome professional CAM, awesome professional analysis, great rendering, great modeling. So there's a lot of applications, and I can kind of guide you to the ones that probably are best fit, or you can try them all.
But there's a rating system in there. But
yeah, so
but Joe's an even better rating system.
Yeah, and this is Visual Cam. It's a full cloud application. Works on my Chromebook or works on my laptop. All the options. This is Visual Cam. It's a full cloud application. Works on my Chromebook or works on my laptop. All the options in the world. I mean, we could have spent the entire time just looking at everything this does. If I don't like this particular cut, I can go to a high-speed cut. I can change the depth. It's a deep, professional, high-end CAD tool, mid-range high-end CAD tool, or CAM tool, excuse me. Okay, but it's inside the document, right? And you say this, nothing's, again, just like everything else. It's a professional, high-end CAD tool, mid-range high-end CAD tool, or CAM tool, excuse me. Okay, but it's inside the document, right? And you say this, nothing's, again, just like everything else. It's a native cloud-based application. And as that goes, I can go take a look at my analysis and see what the results are for a stool. I did this analysis of a stool, and maybe I want to find the results. Actually, I can never remember how to find the results. Well, this is for analysis, so I'll solve it. I can do rendering right now. I can do, and again, nothing's running on my local hardware, so it makes it super easy to go in there and it pops up. You can see the. Oh, sorry, I already loaded this up while I was sitting here earlier, so you didn't see me do it. But here's the results of my, the step ladder, and is it going to be strong enough, right? If I don't want to see the edges, I don't have to see that. This product, SimSolid, if you're doing analysis, go to on there for linear analysis. It doesn't even do a mesh. I mean, in 3 steps, you can do analysis. So there's a lot of innovation going on in the App Store. So I would say my point is try the app. So it'll be very pleasantly surprised.
And it was a Visual Cam.
Visual Cam is the go-to. We can talk, but I'm guessing you probably want visual cam. I think it's basically the option to go to if you want pro level.
Anything for tolerance analysis?
No, not yet. I'm certainly, so I talk to everybody. I talk to every software partner that you can think of that develops something. I've talked to tolerance analysis guys. Typically, you guys have the most clout. If you use a product that you like, send them to me. We have, it's an open system that anybody can add their application and develop on and put it in Onshape, and you're the reason they want to do it. When the customer, a lot of the guys are forward thinkers, but some of them are waiting for the customers to tell them to do something in Onshape. So I think we're done.
Great. Yeah. So give me a second. I'm gonna prepare the food. There's gonna be food here. Joe, I think that you should grab the mic because it's gonna get loud as people are moving. But you should still ask him questions.
Oh, we're doing that.
He's just gonna stand there and wait for you to ask him something hard. So just give me a minute. Feel free to grab a drink, and then everyone can come grab some apps.
Can you make a 3D spline yet?
We don't have a native 3D spline. We have a couple feature scripts. So yeah, you can. So it's coming. Huh? Oh, it's fine. So this is a good example of what it looks like. Yeah. Okay. So we have wiring is routed. It's a spun. Basically, so this is the one we have. I think there's actually a couple of them, and then there's a couple projecting ones that do some different projecting. So yeah, but this does require. So it does. You can, there's some formula ones. You want to put formula, and they let you spirals and different shapes. So when we do it ourselves, we'll probably take this. I mean, this totally what we want. No, we will. Literally, a lot of the times the feature scripts. Our developers use feature scripts when they write the code. So and we didn't write this one anyway.
I want to actually see this as
what kind of surfacing capability have you?
Well, we have loft sweeps. We have, it's kind of a hodgepodge of the usual suspects. Surfacing or modeling well. We have thicken, we have enclosed, we have loft got, guide curves, center line. It's such a hard question to answer because it depends on what you want. And it's
how does it interface with the solid?
Oh,
intersect, trim,
you can sometimes not. I will say that when it comes to all the traditional high-end surfacing stuff, you're gonna have to try. I mean, we're targeting, okay, but that the machine design and the and the 2.5 axis style parts and consumer design parts that aren't going for the class A surfacing stuff, it's pretty good at that. I mean, I could show you. I got lots of examples of different shapes. This one's not bad, a bone screw. This is one that we used to struggle with SolidWorks forever building this shape. And this is using it's actually used a little bit of everything. If you look at how it was built, it's got a lot of sweeps. I think someone created we actually used a little feature script here as well. Definitely have sweep normal. This is one of the traditional, typically a very difficult, shape. I would say if you can, 3D curves are where you need some work. So, and you need 3D curves to get to the surface. Right? So, we have extend, but not mutual trim. We have a single trim. But we update this by every 3 weeks. I don't know if Dave made that clear. And every 3 weeks, new stuff shows up. So you're not waiting a long time for it. And that is pretty high on our list. So modeling, the advanced shape, advanced modeling. Certainly, on our list for high priority.
It's funny because I find myself working with surfaces more than I'd like to in SolidWorks.
Well, you could try, another route. It just depends on your workflow. There is this application that lets you. It's a subdivision modeling. I don't know if you know what subdivision surfacing is, but it's a very push-pull shape type of thing. It's outside of Onshape, but it sends it in, but it lets you create crazy smooth shapes, in a very easy way. But it's more of a, it's not curves, you push and pull on it to get the shape.
Yeah, that's not good.
I mean, we'll be as good as anything out there. Our foundation with our geometry is Parasolid. It's what NX uses. Apple uses NX. I mean, most of the high cars, planes, trains, and automobiles. So the foundation is there. We just have to get the man hours in, implementing it and exposing it in our user interface. Essentially, is what we're doing.
Go back to a feature, change and modify something, and it thinks that it's connected. Just that I select.
Missing references, yeah.
Yeah.
Well, I'm not saying we don't have those problems. I mean, that's kind of one of the problems of parametric feature-based history modeling is when you reference something, if that reference goes away, what does it do? We've done it better, so you'll have less of them. And one of the ways you can really solve that problem is have a system that doesn't make you select an edge, but if you could select the result of something else. So, like sometimes, let's say you got a box on a, this is sticking up. Instead of picking the edge, if you can say, give me the result of give me the edge between these two bodies, or give me the edge between the result of this Boolean. So it's the system is giving you the solution. So it's an indirect or that kind of. Instead of picking the edge, you're picking the result of something else. It's far more robust. It certainly doing that.
That relies on the user to know that that's going to work the function.
It does. It does. It does. Yeah. It's going to be the high-end users that know this stuff. And there's I haven't seen anyone solve this problem in a real good way. It's all about missing topology. If the edge reference goes away, what does the system do? I mean, that's why we don't update the models in assembly automatically. We have more of the context, so that we don't want that. We did it in SolidWorks. Right? We wrote SolidWorks. Dave did it. Dave wrote assembly SolidWorks, and we thought it would be a great idea that every change just ripples through everything. The problem is, it sounds good until you find that things just keep breaking over and over again, right? And it's the law of diminishing returns. Yeah. Yeah, so sorry, I thought I knew.
So just to better understand the 3D version, that's public.
Yeah.
But if you create something private, so just to better understand the 3D version, that's public.
Yeah.
But if you create something private, and want to share that.
You can't, as a free user, cannot make a private document. That's the difference. That's all. I mean, it's only different.
If I'm paying and I've got a private document, share that with the client. He doesn't have an account.
You can still, he can view it. It's still private. You're giving him. He just can't edit.
If he wants to edit it, he's got to.
He would have to. Well, it'll either be public or he has to become a pro. We're not. We can't give it all away for free.
No, I understand. I'm just trying to figure out that. Yeah, it's either private.
The thing to think about is the pro user is king. He controls everything. And we would never make you give up your privacy or make you give up anything. So you can always have a free user work with you. Viewing for sure, access, seeing your data, but if they want to edit it or make their own private data,
come back to the owner.
The owner is the one that has the permissions, right? Yeah. And you can't. We learned 2 years ago the pro user could grant free users a certain a little bit of editing. It just wound up being so complicated that we reverted to just keep it simple. Free users, public. Here.
And that's why I was thinking, I love what you yes. Robotics. Yes. Well, today's discussion, they do, and I also, being a little meeting myself,
It's still class.
No, it's not.
They all did. I mean, there's a bunch of them. CR came by. In the one there, I have a home built village. I don't know. Yeah, so you got actually since they use Onshape to build them. So they'll point you to but you might want to look at now one here was about the hot the problem is some point it's critical to have and let alone all the different controls. You really want to cut with that bill. So visual cam all the depth you want to create. I've used
Yeah, I'm working.
Welcome to the real part.
Well, I mean, I've done so.
Yeah, that's the problem. I built one.
I mean, these are
You can cut wood. You need something
Well, yes,
yes, it is horrible.
Yeah, when you're using your algorithms.
Well, this is.
I have never heard of it. Surface finishes are really, it's like they're taking up a little potato chip layer at a time.
Oh, yeah, so I haven't, yeah, I've been when you guys first came out.
I can keep up with it. If it wasn't clear, I'm looking at it every week. For better or worse, it is evolving really quickly. So, you know, it is a product that really is. Are you an idiot?
Right. So it is. There is a little.
Yeah, thanks. And if you say it's all great.
And that's, yeah, because I've done it so I know all of that. So, plenty of your data. That's better. And I want to do it. They have it running on video, just like a real machine. I want to do it. Yeah.
Okay, so. Will that do it? Well, they started out Oh, yeah. I'm a hard Number one thing I want to do is make sure the road is Then somebody will, and then the next thing that we do is try to tamp up their organization. More production projects, it takes 3 to 6 months, 9 months.
Well, the management everything else.
So now people that they build, I don't know, set of expertise.
I guess
And then work on that. You know, a lot of times we talk about okay, we're gonna move to whole division of work. And then you get there.
So
and
they,
why are we doing this? You have all this stuff.
No, so they didn't anything. So I was like, well,
so it's gotta be small, it's gotta be, the project has gotta be small enough. But it's also gotta trying to see how It's funny because I'll tell you a little more afterwards, but what happened was I was actually we had been interning in college. So the guys were from the college they had a 2D conceptual design project, our design. So we just got what was and then that's all I remember. But it turned out John was an intern So that's how we all do this. Well, that was, one of the controversies when we started solar, we should have a website. It is. I've actually found interesting. SolidWorks. But then once the so SolidWorks had this really like hard and then they got the product really quick. But also everything that we tried them both.
Yeah.
So Microsoft worked great. And we did it, we needed a database. So we basically said, we know this serialization thing. That's built into Microsoft. Turned out it actually worked great as a database, well after I left. So for all these things we tried that we sort of thought, we were so it's basically a solvent used in in the same way as it makes a sense. We were the first customers of PC. So, we didn't do it on SolidWorks was this amazing everything we tried. We sort of like, let's just try that, it doesn't work. I graduated from college. So I worked at Pat yeah.
My understanding is
basically, the next thing is you have to all the these are the
potentially.
In this case, I ran R&D. think about like, SolidWorks. The application then we tried it with people in the great Actually, that's something else. Yeah. One example for that is like every software graduates, every computer science graduate. We're getting around that. A little bit, it's not like it's also something that's I will. I'm going to mention well, thank you for coming. Okay, number one, let's get it on okay, great. All right.
I'd probably say I remodel a restaurant. My prefab parts.
Yeah. Yeah, so that's a big one. Yeah, that's one. I